as we were moving through this, and I don't know the precise date that this happened, but right about in that time frame after we started to move forward, but before we got anything really done, CenturyLink dropped their price of PRIs, the whole full 20 loaded 23B plus B, down to about $320 a month. So we go and we figure that out, and it's about $15 a trunk, and that's about what SIP trunks were going for at that time. So a lot of the motivation, a lot of steam went out of this without being able to really save a lot of money, because cost had been one of those major drivers. But we decided with a little less intensity to move forward anyway. So we did, through June and July of that year, conduct a SIP RFI, and we interviewed 12 different vendors. Got a big group of people together, and this is the SIP, the RFI that Dave and Cindy were part of. And so we learned some lessons from going through this. We learned that not all SIP providers are created equal, and not all SIP is actually created equal. That the technology is mature, but there's a lot of pricing models that are not mature, and that implementation issues exist. I think what we read there is that XO had just gone through a big implementation for somebody, and portability was a big problem, just trying to get those numbers over. And what we also found is that nobody really wants to do just a generic SIP. Everybody wants to add something to it so that they can market it, they can sell it, they can give you something cool with it. And so, you know, when you say SIP, you're not just talking about a trunk that just you can use in some generic way. There's always some problem with it, and that
upsell, value added.
That's right. Well, and then the other thing is that bottom one is that there's no one-size-fits-all possibility, because it depends on what their network is and what your network is and what is on net and what is off net. And so I remember having a conversation with Dave at one point where I was saying, why can't you just give me one cost for a trunk, because we take trunks from them? And he kind of laughed at me at the time, and I've learned my lesson since.
Well, we asked, Brian, don't you get trunks by the megabyte? Yes. Okay.
Well, we're going to talk about that too, because we found out. I mean, there's a lot that we've found out, but the okay. But the fundamental question that came down for us was: do we want to be a telco? Do we want to have our own sessions border gateway, and do we want to try and route all of the calls, or do we want to just drain everything out one pipe somewhere and turn that over to the carrier and let them do that? And, you know, back in the early 90s at IHC, we were doing digitranslation, and we were doing hop-off calls, and we were just using the network to route all of these calls and using our switches to do that. And that was frankly, that was my bias going into this, is that we would use the network some way like that. But when we got done with this, it really, I think the thing we answered was, you're just going to drain all of your calls out to, and this connection that they're going to bring to you is essentially an internet connection, right? It's just a really expensive one, and it's dedicated just for their calls, but it's really just an internet connection. And that's going to be the easiest way to deal with it, and that's really what we came down to. So it's just difficult. So that, you know, the easy answer is no. We're not going to run our own SBC. The carriers all have these interesting approaches. We really liked what Verizon did, you know, because they said, we do bursting and pooling. You buy one trunk from us, and you can do 50 sessions with that. So there's a 50-to-1, and that's great. I mean, if it's only $15, that's quite a benefit, a value, right? And if it's $5,000, then not so much. But so we didn't ask for any pricing in the RFI. We just wanted to know how they were doing the SIP. And so, you know, some of them had unlimited SIP trunks on a pipe. You could just have as many trunks as you want. But then, remember, it depends on whether you're making on-net or off-net calls, whether that's really going to be that valuable to you or not. And then just the reliability. Is one connection to them enough? We probably have to have multiple connections, multiple SBCs. We found out that if you went with level 3 and you did it through Internet 2, one set of SBCs that they used, and if you did it with just level 3, it was a whole different set of SBCs. So now you've got other reliability issues.
And how that ties to risk, as you were saying earlier.
Yeah, it comes back to if you only got 3 SBCs and they're all around the country and you're doing the Internet 2 deal, is that really going to be robust enough? And are those SBCs going to be close enough to you where you'd be comfortable? And is that network robust enough? So, and if you're just going to have it on level 3's network, is that good enough, or do you have to have multiple links in? And so there's all these other different requirements. And most of them say you have to bring our connection in, it has to be dedicated, and you can't use your own internet connection, which there's no reason why you couldn't, except for they just don't want you to. So, we came out with some major concerns: portability, call quality, on-net versus off-net, billing issues. Isn't that really the biggest problem with most telco providers? So through August and September of that year, we reported back to the steering group on the RFI results, and we just made sure we were on the right track. We developed the RFP and we released the RFP. And, that was going along pretty good, but since then...
Should that last slide be 2014?
No, that's 2013. I'm correct on my dates on this. Unfortunately, because that's a long time ago. And we've gone through an entire year, and we really haven't made a lot of progress. We evaluated the RFP in November, and maybe this is a good lessons learned, I don't know, but we, in that time frame, over a year ago, came out with 3 recommended vendors. And remember, we said that one of the ideas was that we had to do a proof of concept. So that was included. That was one of the requirements that they had to answer in the RFP. And so we made those recommendations and went to the University of Utah Purchasing Department, and they would not accept our recommendations. And they said, yeah, you put the proof of concept in the RFP, but it wasn't done to our satisfaction. We're not sure that everybody had an equal chance to understand what you wanted and get back to us. And so we went back and forth with the University of Utah Purchasing for months about this. And finally, about last June, we relented. We said, okay, we'll go and turn around and just put out what amounts to a best and final for the proof of concept. And it turns out that anybody could respond to that, so that there were some vendors who did not respond to the original RFP that then responded to this proof of concept. And there were some other good things that came out of it. One of the main vendors, and their name will come up, you'll see them later on, but they dropped all their costs for the proof of concept, so that was really helpful. And so good things happened. That was out for 60 days. That came back in. We've evaluated. I think we've got University of Utah Purchasing on board, and so in December we went to the USHE CIOs and we reported out on got results from that BAFO, that best and final, and got some input from that group that they wanted to put together and convene a working group, and I don't know who else is going to be added into that, but they want to actually go through and redefine the requirements and develop all of the goals for the proof of concept. And so we've gone through and learned some lessons about this. The motivation of cost savings changed a lot in the middle of this, and so that took a lot of steam out of this. We learned about the functionality, the proprietary versus what's basic SIP, and that there is no such thing really as basic SIP. One of the problems that we have is that there is an issue where we would like to have a one-size-fits-all solution. And the fact is that for us, when we look across that, we've got Utah State that's in Logan and Utah State that's in Blanding. And the fact is that we could bring all of that traffic up from Blanding up to Salt Lake and then send that out. But if the local calling is not on net for that provider to Blanding, then you would incur additional charges and costs by doing that. And so even though, Eric, you've been a proponent of this one size fits all, of this, let's get one product and let's not make it any more difficult to deal with. And I'm supportive of that. But I don't know if, there might be a vendor that we can find that will take care of us with that issue, but it just depends on what the on-net and off-net realities are there. So, so there's issues there. There's issues with reliability and then the portability. Just how are you going to be able to deal with each one of these areas? And so where we're left right now is that you probably want to know who the winners are, and I think that we have not yet finalized that. And so I can't really go through who those are. But I can tell you who we were impressed with. We like Net Diverse. They've been in the SIP space for a long, long time, and they're very good. And we like Windstream. They're the ones that have a pipe that is just, you put in 2 meg pipe, and then you put as many calls across that as you want, and they're happy with that. You can do as many trunks as you want. But so put in whatever size pipe you want and do 3, 4, 5, 10,000 trunks. Get all your friends to provide the same trunking group with you, and then do the DIDs for all of them, and then that would be an amazingly efficient way of doing that. And you get down into where trunks potentially could cost as little as $1 or $2 a month to have those in place. So they're pretty interesting. CenturyLink, they waived all of their upfront costs in the final proof of concept. So everything else they do is pretty good. They still are a telco that's dependent on the copper-based stuff, so it's a little concerning to us on that. And then Broadcore, they're the ones that have developed all of the really good SIP software, and so they provide it to all the other providers, and they also have it for themselves. So we liked what they were doing. And then Verizon didn't respond, but we liked their pooling and bursting, and we wish they would have responded, but they're not very big as far as the telco part in the state of Utah. So they responded to the RFI. We really had a good discussion with them. Those of you who might be in a better Verizon territory, you might want to contact them and see what they can do. We never did get pricing on what a trunk would cost, but if every trunk comes with basically 50 trunks and the price is right, that could be a really good way to deal with it.
It's interesting they responded to the RSI, but not the RFP.
Yeah, we were really disappointed that we didn't get them to respond to the RFP, and they didn't respond to the FAFSA either. So.
How many of these providers that you guys like have last mile to your locations?
All of them would have to go over a different last mile pipe. I think every one, CenturyLink is the only one that really has that last mile. So I don't know if it's a type 2 circuit or just somebody else's internet, but they all partner up with other internet providers. They're really, all of this an internet link. It is really a costly, when you think about it, it's a very costly internet link, but it just is dedicated to them. So one of the other things that we have to figure out is who has good redundant paths and good redundant SBCs and can take care of you that way too. So, it just comes down to who's got the best on-net plan for you, because you don't ever want to have to go off-net if you can help it in your calling patterns. You have to really make sure that you know and analyze your data of what your calling patterns are, and that was a handicap and is a handicap to UEN because we don't have all of your records about where each one of the facilities is actually calling, because we don't keep any of those or have access to any of those. So we're guessing what's going to work and what's not going to work, and we really think when it comes right down to it, you're probably going to pick, if you're in a UEN position, you're going to probably pick 2 or 3 vendors that can do this. And then you're going to have to go into each one of the facilities and get all of that call detail and figure out what your calling patterns that are most on net and see which vendor actually does that for you. Because if you go off net, then you could go up to 1.5 to 2 cents per minute per call, which isn't scary if you're talking 1989, that's really good. But if you're, in our environment, that's
That's what CenturyLink rates are, right now for long distance.
yeah.
I mean,
So you're just going to be paying basically a long distance. But if it's something that you're normally used to having no charge at all, that can throw. No, none of these are big scary numbers, and it's part of the problem with voice right now is that the pricing's come way down. When it was $1.50 to call from Salt Lake City to Dixie, St. George, then there was a lot of incentive to do things, and now when the cost difference is between 0 and a penny and a half, 2 cents, it can add up, but it's not big.
We did a similar thing. We got 4 or 5 pricing and various scenarios. There's so many things. I agree with every bullet you've made. I noticed you didn't mention 911 as one of the things looking at.
The E911 is an issue.
Yeah, I mean, when we do moves, adds, and changes on phones today, that's a manual process that we're doing to update the PSAP. I'd like it to be automated in our next generation solution. And I got different answers from different respondents.
Yeah, I don't think there's
on how
any
they
really
deal
good
with
way to do that right now.
Well, like Windstream, they still want you to go into a portal and do them one at a time by yourself, where others would be able to facilitate a database.
And I didn't call it out specifically, probably should have, but just that whole implementation piece, the portability of the implementation, it's just not easy right now.
Yeah.
The technology's simple. They've been, the carriers have been using SIP and packet voice, and that's all this is packet voice, forever. I mean, you go back in 1988 when we first evaluated putting something in for IHC and talked to all the carriers, and they were all doing this thing. This is a very mature technology, not a problem with the technology. Scott?
Did your proof of concept include an on-site trial with all?
Yeah, every one of them would be put into a different institution, and so we'd go over and look at the calling patterns. So we'd get every one of these groups involved. You have to figure out what's going to actually work based on what you're on net and off net. It all comes down to, no matter what, everything else that looks like it comes down to what is their network, what is your network. And you're not going to put in your own SBC. There's no way, because if I have to figure out where I need to deliver every single call that could possibly happen to every one of your sites within the Union network, and there's 1 million plus possibilities there probably,
I think you have
it's
a
not
much
going to happen.
bigger, harder problem than most of the single
Yeah, I agree.
Yeah, and if you're going to be a single campus, and we looked at that, and with Cindy and Dave, one of the things could be that we turn it over, the campus could run their own SBC, if that's what you want to do. If there's any money in that, I think just the economics of this are such that turning this over and just letting a telco take care of this, that's what they do, and then just figuring out how you port all the numbers over and you account for all those numbers and let them do the routing, and find somebody that has a good network, that you're basically making all on-net calls.
Kind of where I was going with that first question was, did you have the on-site trial long enough to get a sense?
So we haven't had any on-site trials yet at all.
That's coming.
That's the problem. And we were hung up for almost a year at the University of Utah procurement.
Did you say that you had on-site trial?
The proof of concept site traffic.
Well, proof of concept will be, but we remember we wanted to award it in November of 2013 and move forward.
Yeah.
And the University of Utah purchasing department said, you haven't satisfied the proof of concept requirements and you can't make this award. And we went back and forth with them, and we contended for months that we've done everything that needed to be done, and let's just go ahead and move forward. That turned out to be the wrong strategy. We should have just said, okay, you're right, let's put it out for 60 days, and we might have been able to start the trials a year ago.
Yeah, I'd say that.
But we thought, well, we'll save time by arguing with them. That didn't work out.
Are you guys actually gonna move with the CenturyLink drop prices?
It really comes down to the steering group. Remember too that this isn't anything with the K through 12. This is just in higher ed. And so what we haven't begun to address, and what we're probably going to need to think through, is what happens in 5 years when all VoIP and voice reimbursement for E-rate is gone. And when those schools start to lose that reimbursement next year, they're probably going to be pretty motivated to something like this, and it actually may save them some money to do this. But the cost savings now are not in the cost per trunk, although they could be if you can get them down to $1 or $2. Yeah, that's true. With the Windstream, it is. Yeah, but it's going to be. Yeah, maybe that's where it is. But yeah.
I mean, at the end of the day, isn't really everybody just gonna cost shift this onto their employees' cell phone? I mean,
That's what our co-host
really?
said. Yeah.
It's already happened with me. In fact, for the last year and 9 months, have had my own cell phone that I pay for myself. I don't even get reimbursed from the University of Utah anymore. And I don't use my desk phone. The only number I have is my cell number. If you want to get a hold of me, I don't think I even checked my voicemail at the University of Utah campus. And who has a corded phone anymore that they ever use? I really don't.
People want to have like
It's black.
What?
Can I hear you yet?
Yeah, uh-huh.
Oh.
Yeah. And
Oh, there's definitely
and
this
shifting that
whole
traffic.
quality issue that you don't get.
I was gonna say, even with the cell phone, then you're into your DAS issue, then you're into, okay, you don't have a DAS and you have low quality, okay, it's moving to VoIP over Wi-Fi, or you just shifted the traffic to your Wi-Fi network. I mean, it's munging around, it's moving.
Well, there's the biggest problem. So we did we put together a group 3 or 4 years ago, and inside of UEN, and really did this study, and I didn't include this information in the presentation, but we did a study, and when we came back, what we said is, if you move your VoIP traffic, so this wasn't SIP, this was VoIP, but there was a hosted VoIP issue, so if you move, and you think you're going to save money by moving onto the UEN network, and that's all fine and good, but the UEN network is a best effort network, and there are many single points of failure on our network. And if you think you're going to get the same quality and the same reliability by moving to VoIP across the UEN network, you just won't get that. And you get that maybe 95 or 98% of the time, but there will still be significant problems that you'll get dinged on by your users because our network won't be up and available to you. And if that's at the wrong time, that can be catastrophic. So, I think it's one of the biggest things that we're wrestling with at UEN is people love our network. It is up a lot of the time. And we are a 3 nines, 3.5 nines network. No question. I mean, all the time. And most of the time we're a 4 nines network. And some of the times we're 4.5 nines network. But never are we a 5 nines network.
Neither is our cell phone network.
Yeah. Yeah. Well, when that goes down, it's somebody else's problem. And I have a lot of heartburn with UEN, how it affects us. So, anyway, we'll keep you posted as we go along. And thank you very much.
Thank you.
All right, Michelle Bennett is going to present on IPv6 update. And Michelle, just so you know, yesterday, one of the discussions about the cyber infrastructure plans that are required for NSF proposals, we all agreed it was probably going to include IPv6 and include security on IPv6. So it's timely, and you're going to submit a proposal. And for those newbies, Arizona State is recycling. This is plastic, this is metal. Saran wrap does not go in the recycling.
Okay. I think I failed that test already. Not saran wrap. That's a lot.
Thank you, Marla.
This is plastic.
Well, thank you. Michelle Bennett from BYU. I presented last June on IPv6 coming to BYU. And so I was asked to come and give an update. And why we decided to go to this is for the obvious reasons, with the lack of V4 addresses and the potential holes that you can see in accessing different sites, or people coming into your sites from V6 address and so forth. The vision was to basically have virtually unlimited addresses at BYU, provide that global reach and global visibility. And so we went down the path, and since June, we've had bi-monthly meetings that we sat down and discussed kind of how we can continue to make the progress. We presented some of the ways that we had progressed up to June, which in June we had the assignment from Aaron as far as the V6 addresses and or the space. And we had also the MPLS path, which was kind of that virtual path that we selected certain people to be on to help pilot and test it. We had also gone to our ISPs and made sure that we have that connection with V6 to all of our ISPs. And we also looked at UEN and made sure that that was IPv6 enabled as well. And as far as the data center, that was included, and also the IT building. So since then, here's a graph of, it went up to November. Kelly actually provided this graph, but this showed that even without users knowing what we had done with the MPLS, that our traffic across IPv6 has increased a lot, and with just a few users, of course. And this again is them really not understanding which path they're using. They're just enabled, and whether it's V4 or V6, they didn't really know, but the traffic is going and increasing over that.
Michelle, is that internal to your campus, that traffic?
That's leaving the
Yes.
campus.
Oh, it's not.
What did you say?
It's leaving the campus.
Leaving the campus.
That's probably because people are with the dual protocol or dual track network, and they're not realizing that when you go to Google, you're going to IPv6.
And to that point, that's a subset of one building on campus. We only have a half dozen or a dozen people on that dual stack VLANs in one building.
Yeah, there's just a few.
But the growth is still going on.
So since then, we did go back and this was kind of interesting because, as I mentioned to you, we had the bi-monthly meetings over and over and said, you know, how can we make progress on V6 and kind of take that step, and we did some testing with Clip, which is in the lab to make sure that we could upgrade that and get that ready and so forth so that we could take the next step of DHCP and DNS. But I would say probably the biggest catalyst to get us there was the fact that Kelly McDonald retired. And our engineers really wanted to give him a going away present. And
So that's all I want for Christmas is IPv6.
It's probably good you're retiring.
So they hunkered down and went ahead and enabled dual stack within the ITV, the data center, through our core, and so that we could get to our ISPs through V6. And so it's no longer reliant on the MPLS, but we can do that. This also provides us a way to basically now it's within our core, and so the only thing now we need to do is kind of scale up the rest of campus as needed. So we did that, and how we did that, of course, is making sure that not only dual stack, but we had to upgrade our routers so that they were IPv6 capable. And we also, as we do our next gen upgrades within the different buildings on campus, we make sure that they are capable of also having that dual stack capability. We've also defined all of our addressing for campus, and this is the format that we use. We basically provide that /56 for the host to use as they will, but have it pretty categorized so that we understand what's going on across our campus.
What does USE stand for?
Use.
Just the type of network?
Yeah.
Like it's user, server, you mean like that? Or
Now the big one probably is do we allow incoming connections or not?
Okay.
Or is it a special purpose of physical facilities, Internet of Things type use? So very high level.
And you don't have a different designation for different campuses, just building, no site
Yeah,
equivalent?
one campus.
Probably the biggest one there is our 07, which I think is on the next slide, 07, which I'll get to. Comment. Okay. And the other thing that I was excited about, and I shared this also. Jeff? Jeff, yes, okay. So Sean called me up and.
Yeah, that's me.
Yeah, okay. Sorry, this is for me. That I shared that this was the point I made in my slide. So we had a CS conference, which is just where the infrastructure teams from the different entities, the church entities, kind of come together and have a conference on infrastructure. And during that, they talked about IPv6, and what came out of that is we also have a listserv that we kind of share information on. Not as much as I'd like, but we do share IPv6 information on there. And out of that came that BYU Idaho just jumped on the bandwagon and went ahead and went towards implementing the V6 on the campus as well. So I was when it's done. And I know he had December as the date, so that's good. That's good. So we were excited to hear that. I think a lot with V6 is just sharing the successes, sharing that you're going and kind of having that collaborative approach as you get there is what we've seen. We also, as we think about new technologies, new architectures that we're putting in play, we do ask the question, what about IPv6, as Marla mentioned. Some of the cautions that as we have gone down this path, we want to make sure that we deactivate tunneling. And we have some port restrictions that are in V4 that we want to make sure that we kind of mirror in V6 as well. And the other thing that we're not quite here yet, but it is a concern of our engineers that the Windows client configuration, when we do enable that, or do put in DHCP V6, that we have to disable that auto configuration on the Windows client is one of their concerns. So, and how to do that, we haven't quite got there yet. So next steps, it is to upgrade our IPAM. As I mentioned, we have tested this in the lab and that's complete, but I think this is more just taking that push again to get this done now. And I know that we went through a process during the holidays to upgrade our border firewall, which kind of took some of our resources off of this. And so now they're focused back on this. And interestingly enough, during that upgrade with the firewall, we found that our complexity with NATing actually was one of the causes that we had a hard time with during that upgrade. And so going to V6 hopefully will help eliminate some of that as well.
That's what you're using for IPAM?
They call it Vital IP.
QIP.
Vital QIP.
Lucent.
We call it Quest, that's what I was going to say, but.
And would you recommend it?
Well, my understanding.
Consideration.
I'm sorry.
If you can get the agreement we have and prices are number one consideration, it's a great. If features are your and usability are your primary.
My understanding is that we were grandfathered in at a really good price, which is why we still have it. So. Okay.
Sometimes free isn't actually the
Good,
best.
exactly, yeah. So we are, I wouldn't say actively entertaining, but it is thoughts that we have spoken about. What are some other solutions there? So, and really the biggest next step is just to ramp this up throughout BYU. Now that we kind of have the core in place, it's just going out there, talking with our CSRs, and getting people to take that next step of the capability of the dual stack within the different buildings distributions. So,
Can I just comment on that?
Yes.
Just to your point, we don't want to surprise the campus. There's sometime will be some kind of hidden dependency, transitive dependency potentially. So we are creating a set of mirrored VLANs. So we got the VLANs that people are on today. and then there'll be a mirrored VLAN, which is essentially a dual stack equivalent.
Right.
And then it's up to the CSRs to tell us when to switch them from one VLAN to the next.
Right.
The CSR of
Computer support. Distributed, yeah.
Distributed IT.
Right.
Yes, thank you. Sorry about that.
Do you explicitly gauge on those VLANs? Or
I didn't hear.
do you need, you know, several hundred support hours?
So we are intending on using DHCP v6. We've done the rounds on getting the user Slack, and we've decided to go down the path of explicitly handing out addresses, go in a random fashion. So out of your /64, it'll be a random address in that /64.
I've noticed that particular thing doesn't seem to be as common as I would think in the IT. But I guess I was also asking, are your clients currently using DHCP? I mean, can you essentially flip a switch and move everybody to the dual stack?
Yeah, the router tells the first thing the client does is ask the router how to get an address. I mean, it looks for that. The router says use DHCP v6.
Right. No, I'm asking, do you have people using static addresses on your network?
About 95% of our campus network is DHCP, whether it's a manual kind of a boot key configuration or a true DHCP protocol. About 95% of our campus.
But in
V4 DHCP.
And v6, we're trying to just only have servers with static addresses.
You know, just an observation, Kelly, we notice you keep using the term we.
That's under negotiation.
Very good. And we will be setting up the public and private domains, basically kind of as a way to replace NAT in some sense, so that we do allow inbounds coming from 3007, for instance, as a use case, and allow everyone else to go outbound, but only the ones that we designate to come in. Right. That's. And then, of course, we still need to go and investigate some of our other major business devices, such as the telephone, the IP phone system. This is going to be one of the things that we are going to enable the dual stack on next, and basically watch that and see how that goes. That's part of our next step. And security-wise, we are, when I was talking with our engineers about this, I said, well, you know, it's probably time to get security more involved. And their comment back to me was, well, I'd like some recommendations other than don't do V6. So we're still kind of working that angle as well. And that's probably about it for right now. Yes.
How big a space did you get from Aaron to start off with?
40.
We get those IPv6 addresses.
And I think BYU Idaho applied a few months after us, and they got like a slash 36, if I remember correctly. So they're handing out bigger chunks now.
We were actually asking about /48, and it's like /4 backwards. And that's for the other one back. They're easy to get.
So did Union get IPC?
We have 2/32.
Two.
Yeah, we've had them for 10+ years. Back when you had to be an ISP and you had to meet certain criteria. And we've allocated those out so that all of the colleges and universities get, I can't remember what it is. It's a million networks.
Yeah, so we did the same thing. We got a /32 as a provider, and then we allocated 48s out to all of our members, but they're all going out to be in their own space. So, yeah.
Does that make you uncomfortable? Like they might leave you?
I thought it was a great reason to stay with us. As it turns out, maybe not so much.
Now you can get it.
Okay. Thank you.
Thank you.
So they're never checking you, but.
Every year, it's like, the next one will hire. We say, we all have, we're given to us. And we've done the work. Well, we just give it to them. They register, they maintain it. It's not like we're gonna actually.
All right, Scott's gonna do this panel on CCIE, NIE. Are you gonna, touch it all on the news and solicitation?
Yeah, yep. Okay. So last time we got together, there were a number of Westnet members who had been successful in applying for and receiving grants from the National Science Foundation under what was then the current CCNIE, Campus Infrastructure proposal. And so we thought it would be good to share some experiences with that for those that are interested in applying for the same. So we have a panel of Brian from University of Idaho, Gil from New Mexico, Bob from Wyoming, and Thomas from University of Colorado. Thanks for showing up, Thomas. I wasn't sure if we'd see you yet today. And we can share some of those experiences with you. I'll add that yesterday we spent quite a bit of time talking about the current solicitation, which is not CCNIE, but instead CCDNI. And I'll have a link to where you can find more information about that. We had some really good discussion yesterday, and if you're interested in applying for an NSF grant, that would probably be the one you'd go for. But I think that today we can still cover some basics that should prove useful to you. So rather than stand people up in the bright light in front of you all, there's not really chairs, so I thought we'd just go around and hopefully people can speak up and you can hear as we go through. So these are the questions that I thought might be of interest to you. So Brian, why don't you start with a brief description of your project and the amount that you were funded.
Okay. For University of Idaho, we were asking for to support data science, and so it was kind of characterized. I tried not to take offense of eliminating the network bottleneck to allow true 10 gig capability, and so we were funded $477,000 to do that.
Hey, Gil?
University of New Mexico was funded $498,000 to deliver between 40 and 80 gig connections across upgraded to 100 gig ring on campus dedicated to research. In that same discussion, we've upgraded our connection to our gigapop to 100 gig, and then we're adding 100 gig connections in gigapop as well.
Thanks, Bob.
I got my slide here, but Scott said I couldn't submit it. Anyway, we got a grant for $500,000, and it was to create a science DMZ and upgrade our connection to the internet to 100 gigs. So what we've done with that is, Marla talked a little bit about Frontline's Gigapop, but we've upgraded in conjunction with the Frontline Gigapop members, both connections to the internet to 100 gigs. We're upgrading part of the Bison ring to 100 gigs to Wyoming. We're implementing a new edge firewall that supports 100 gigs, and that's what we're developing the Science DMZ. And then hopefully there'll be some money left to distribute this to some strategic places across the campus.
Great, thanks. Thomas?
Okay, yeah, we got 495 from
to upgrade an existing, I mean, that was the title of our proposal, to upgrade an existing science DMZ. And it finished this summer, the project was a 3-year project. And we basically put in 2 new border orders to really separate the traffic before it was still crossing our firewall, to improve the network design. We have now 40 gig links in certain areas, and up to the core is connected with 80 gigs. We integrated performance measurements and key points, security, added a full cluster to our science DMZ, and added with respect to computer science, kind of an experimental software-defined open flow networking area.
Thank you. CSU received also just under $500,000 to do a very similar infrastructure upgrade on our campus. So here's 5 campuses in the context of Westnet that recently received about $500,000 each. So it's real money and quite valuable. And I would encourage you to apply it. I think it's worth the time. So how about key elements of your proposal that you thought were really beneficial and essential in terms of your being successful in receiving an award? So Brian?
I think one, we had multiple organizations that would benefit, so not just University of Idaho Moscow campus, but we partnered with INL and brought 10 gigabit into their high performance computing center, and so that showed that we were working across the state with benefiting more than just one organization. And then we also had multiple science projects that would benefit that were sponsors of the project. So both the Northwest Knowledge Network activity that's going on and the Institute for Bioinformatics and Evolutionary Science. And so those 2 projects were supported and co-PIs.
Okay, great. Gil, how about?
We went out and interviewed 20 we consider to be key faculty across campus, including the Cancer Center and some folks in health sciences. We, in essence, be careful not to suggest the network was deficient in any way. Put testing equipment across all the ends of the connection for all the faculty. Provided coordinated, in essence, of what the network performance was designed to do. Assuade the assertion that 1 gig connection cannot get to 10 gig without some additional assistance. And then we basically captured their science requirements, using it as the lead activity as part of the proposal, and put that in front of NSF and said, these are the science requirements for the campus, that the network is an instrumental on the tool. And so we believe that we have a very good idea now of what our requirements are for the next 2nd, 3rd, and 4th iterations of our redesigned Science DMZ, redesigned the campus network, redesigned and work with our colleagues in the State Tech, etc. So it's entirely driven by faculty requirements.
Thanks. Bob, Wyoming?
I'd say, the same thing applies to Wyoming. So I mentioned yesterday, these things, the speed is only as good as the weakest link in the connection. And so a lot of the researchers are disappointed with the speed they have. But we tell them, you can't run this through a 10 megabit hub or a $100 USB disk or something like that. It's just not going to perform. So we're working with the researchers to try to explain the whole problem, what the real expectation should be, and to look at the whole end-to-end path to determine, are they using the right protocols? Do they have all the right equipment in the path to make it successful?
Thomas, in your proposal, what do you think was key to your success?
I think we had pretty good requirements and data. I mean, we worked with our National Snow and Ice Data Center, and they gave me nice graph on their data transfers and data requirements. We had engagement with physics. So physics, we had our storage system where we had these 100 million files that were transferred from an instrument. So I think we had a nice set of in physics, NSIDC, psychology, computer science. We had a nice set of applications.
Thanks. Our campus, or our proposal, I think, hit a lot of these same points. We had some what we call key research faculty that we solicited some text for the proposal and some very, what Pat likes to call eye candy, some diagrams or graphics that we could include in the proposal that really caught your eye and brought some attention to that. Paid a lot of attention to the cyber infrastructure plan, and if you go back and review some of the comments from yesterday, you'll hear Kevin Thompson, the program director at NSF in this area, really hone in on how important that is. Paid a lot of attention to that. And I think that we made a case for requiring this network upgrade, illustrating the science that required that, and we're careful to tie those two things together. Next question, as a grant recipient, what outcomes do you think were most impactful for your institution? Maybe we'll flip the order this time and start with you, Thomas.
I think this information that we have in water orders, let me look at our networking, so that we really have a real separation that then it doesn't have to go through the firewall for research traffic versus the commodity traffic. That's the biggest impact.
Bob?
I think that the outcome to enhance science, we'll figure out how to prove that, when we have to turn in the results of that.
Right.
But, yeah, I mean, the thing is we've got to demonstrate that we do have a need to transfer a whole lot of data quickly. And that's really the main thing.
Okay. Bill?
So probably the most important outcome is that IT is spending their time to listen, to propose solutions that are aligned with the requirements of the researchers who have historically either tried something and just didn't work and walk away, or they called maybe one of you or the campuses to meet their needs. So this is as much a culture shift as anything else, and IT becoming much more aligned with the research requirements on campus, and to a very strong collaboration, establish underlying foundation coming out of central IT that's going to be responsive to those requirements.
I think that's a really exceptional point, and even if we weren't successful in receiving funding for this, one of the benefits of going through the application process was certainly to open up some of those dialogues between central IT and our research faculty. It's quite beneficial. Brian, how would you answer this question?
Yeah, there's kind of on the technical side, we've been having to put a 10 gig upgrade into a grant proposal every year for that weren't infrastructure grants, and so this took that off the table. Now that hurdle's been cleared. And then the other part I was going to talk about too is that we're talking with some of the big data science teams now as central IT, and we're talking again about this year, what do we want to do for the NBI proposal? So it has facilitated that communication and not just operating independent of each other and occasionally say, hey, give me some numbers to stuff into this grant.
Excellent. So for Colorado State, this third question, the jury's kind of out, and we basically lost a year in this process. In that, at the time, we had Juniper routers on our border and Cisco routers in the core. We thought, boy, this would be an excellent opportunity to standardize on a single platform on our campus. So we worked with Juniper on a design, and they assured us that the MX series would be outstanding in our core. And we spent probably 6 months working with them trying to make that platform successful in our environment. Because of the way we do VLANs and a number of other things on our campus, it just was a horrible fit, despite the fact that they were outstanding in the border router role on our campus. So we spent the next 6 months trying to figure out how to ship that back and get a refund for that. And so a year later, we finally went with replacing our Cisco equipment with Cisco equipment in the core, and that seems to be going much better for us. Next question is, what's been the impact on your research? And probably more important, kind of getting back to Eric's third question, right? How do you measure the success of that? So Thomas, why don't we start with you again? It's your question.
This is actually my question,
Yeah.
but I don't have a very good answer here. I mean, I think we're measuring data transfer, so we show how much data is transferred into the physics, the open science grid, we measure data transfers to Globus. But I have trouble, and I haven't really found a good solution. How do I link that to specific research projects to really show, and I think that requires more kind of manual work to go and talk, and that's something I haven't really done very well, to link it to a specific research project and showing, hey, this is something now we can do that we couldn't do as well before, and I'm struggling with that. So I'd like to hear from others too, how they link this to the research outcomes.
Yeah, I mean, it's the thing that concerns me the most is that at the end you have to demonstrate how it really get enhanced research. And so, we'll be trying to figure out the metrics and, to show the science that was enabled as a result of this.
Yeah.
So since we have pre-test data on all of our projects that were identified in the application, the post-test will be the variance throughput of getting access to either local campus computing resources, local storage, research storage, as well as services offsite with our colleagues. The other impact has been that we have agreed to work with 4 comprehensives in the state to help them write the small institution grants to be staged so that they can gain access to UNM and NMSU and tech resources as appropriate. So the long-term impact is the research community now has a vehicle, always to have a dialogue about services between the comprehensives and the researchers.
Excellent. Thanks.
Yeah, and given that we did have some more measurable pieces of this, of wanting to get past the, be able to get to true 10 gig of connectivity, so in that sense, that's been very measurable. The NKN team is regularly able to transfer 3 and 5 gig between Idaho Falls and Moscow. So that part's been measured, although now that they're measuring, they're asking us a lot harder questions now with their per sonar servers of, well, why is it variable? Why is it faster some days than others, or sometimes than others? So that's more of a dialogue that we're starting to have with them, and with Iron and the other partners, of what is going on. Is there a misconfiguration somewhere? Is it just traffic load? How do we characterize that? How can we explain that?
And that's a good point too. I think one of the other perhaps unintended consequences of receiving this is exactly that, and how can we be more effective as a central IT community in supporting our research folks and helping them determine exactly where that is. And I think the per sonar boxes will go quite a ways in helping that, trying to figure out where those bottlenecks are. Again, since we've been delayed, we don't really have much of the way in terms of a final impact to report this time. Oh, I can tell you that our genomics folks run sequencing and they throw the data away because they just can't afford to store it. And they still are great customers of FedEx next day because they don't have the time it takes to transfer the data over our internet connections, even though we have a dedicated 10 gigabit link for the research community. They can't access that effectively yet. So I have to commend the panel. I knew we had 4 panelists, 4 questions, half an hour, and I said we have to be brief, and brief they were. So we were a little bit ahead of time. I guess one question that I had that I took off, thinking we wouldn't have time, is what advice would you have for others that are thinking about applying for an NSF grant? Brian, let me start with you on this one.
To me, the big one was to listen to the project manager, the feedback they give you. For example, we didn't have Science DMZ as part of our proposal, and we didn't have Personar as part of our proposal. Surprise, surprise, they came back and said, these are big misses that you have. So they're open to that. They give feedback, and built that into our plan, and, and that made our proposal a lot stronger.
Okay. Gil?
Seize the opportunity to work directly with researchers.
Yeah.
And so take the time to listen, put people in front of them who are well prepared to not only help in preparing the vignettes or whatever case studies, but more importantly, be able to articulate the research needs as the underlying foundation, whatever technology gets recommended by the organization. And be open to the fact that it may be very different than what you're trying to do. And it may influence other things. So one small example, because of this grant, we just re-engineered our data center using almost all the same concepts that are driving our science DMZ and our campus research network. It is completely flipping everything we're doing in our data center. And it's a very appropriate, right thing to do.
Good. Thank you. Yeah, good. Bob?
Come from a small state with a bad economy and very few people, and the EBSCO pays more attention. Seriously though, I mean.
Right, for those that can't redefine our state, what it's
Yeah, I'd say, the main thing is to identify the research and the researchers, get them involved. And it'll, make some development proposals.
Okay, thanks.
Can I add one thing, having received a number of these ourselves, the one thing I would add as a learning is, don't let your organization think it's a free puppy. And I mean, the problem is you get these grants and then it wears out and then you have no money to replace it and people are dependent on it. Right? And it's, we have so many free puppies that cost us a lot and nobody's done a good job all the time of communicating what the ongoing costs are going to be, what the replacement costs are going to be at end of life, and so you have all this sunk, expectation in the research community that, oh, we have this new thing, and then, unfortunately there are no free puppies, and every puppy you get has to be taken to the vet and has to have its regular things. Unless you want to put it down, but it's
first bag of food is free.
Even that costs money. Putting it down even costs money. So that's my caution, having staring it in the face all the time. It's from CCNIE and others. That's
so it's a lot of money. It's very beneficial, but it requires a little bit of management of expectations.
A lot, and the thing is it's just, unfortunately Moore's Law isn't helping us as much as it used to. It used to be that you could have a $500,000 grant and get you kicked into something, and then it's only $100,000 in 4 years to get it to replace. But now that doesn't exist anymore.
It's just your 400,000 or 500,000 buys you something better. Thomas, what's your advice for folks wanting to get in this game?
I like the copy, and I think we put it, if I'm not mistaken, I'm looking at David here, I think we put it into the cost model for our network auxiliary to replace some of the equipment. So I think we try to basically make sure we have a path forward. It was a little bit easier for us. I mean, we had already started a science DMC, so there was already a concept there. It was just really giving us the push to upgrade. But I think you have to make sure you have some plan forward, and that's always challenging on research infrastructure. It's hard to spend a lot of time to.
And we got a $500,000 grant, but we spent half of that also of our own.
Yes, but that was one of the prizes when. I didn't know when I wrote the grant that we needed a third chassis because nobody was us to plan it. So we spent quite a bit of our own money at that time.
Right. Well, most of these grants don't necessarily have staff or the funding to actually install all the hardware you're getting. Yeah. So, I mean, you really need a commitment from your organization. It isn't free money. It's money to help you potentially do something that's good, but you have to have the commitment for the staffing and for the ongoing support of it. And so, yeah, I will note there was a presentation yesterday. This is part of the effort of the CCIE is to look at this, for how to submit a proposal and how to sit a talk on how to engage your researchers. So I encourage you, if you are going to submit, I thought both Pat and Thomas did a nice job of discussing that. And NSF actually, the new science director came and presented, videoed in to present, and Kevin Thompson, who's the program director for the new solicitation, and has been for all these CCIEs, also presented. And he, we specifically asked him, for UW and some of the smaller schools, what research means to them. And it was sort of interesting that he said, oh, well, yeah, we should have changed that language to say research and education. So I think that's something to really keep in mind. If you have strong educational drivers, especially interregional or intercampus, to write those up as part of your proposal. And so it doesn't have to all be the demand networking, obviously. It doesn't all have to be what we would call traditional research. So that was the first time I heard NSF actually say that. So that was.
And I think the other thing is, for me in the institution, it validates. You get a grant, and even if the university has put stuff in, it's not crazy ideas Thomas and some researchers have. This is really peer-reviewed. This is a valid concept that's valid to pursue. I mean, I think that's the other thing. It gives you some type of more credibility. Hey, this is really how networking goes in support of big data science. And I think I look at this as I think it validates. Hey, there's some ideas you have, and you get funding for it. So somebody must believe that's valuable.
So if you weren't here yesterday, you can access the materials that were presented and Kevin Thompson's participation in that. He gave a lot of really good advice on how to apply for the CCDNI. And if you're thinking about doing that, I think it would be well worth your time to check those materials out, and they're linked off the main Westnet page there. So that's what we had. Any questions for any of the panelists? Yes.
I have one question. So being from a large institution here, how do you reach out to those researchers? How do you open those doors? Because they're operating in closets and backwards.
So that's a great question. One thing that we did was we went to our Office of Sponsored Programs and asked them who had recently received significant NSF grants or NIH grants. And so we took that information as a way to reach out, because we know that they're recent grant recipients, and ask them about their research. And you might have other ways to kind of tease those folks out, but in our experience, that turned out to be pretty effective. Any other ideas about how to find? Yeah, Joe.
No, the method we use the selfish interest model. Then, so the selfish interest is derived by some people using our HPC organization. So we simply take their customer list and started making phone calls and asking whether or not the services they're getting from HPC would be improved if they had a different type of network connection. And then invite them all kinds of interesting conversations. So the good, the bad, and the other.
And then we created, when I started, an advisory committee of really faculty, kind of big hitters in the different departments, or generally to those, and then there are multipliers, and so. And then approaching on our own, I think we try to get out there and talk to faculty and go to seminars, and I mean, there's a lot of legwork involved. There's not much. Yeah, they don't come to you and talk to you generally. They
nothing to do with you.
Yeah.
Unless they have a selfish.
Right. Yeah, that's pretty much it.
Yeah, I think our CIO has just been making an effort to meet with the VP of Research more and try to identify partners.
We talked yesterday a whole lot about the importance of establishing and maintaining relationships, and I think that's something that if you haven't done a good job of in the past, something that an initiative like this might help you initiate.
I have found that if you really just need research and you can't get your researchers or your colleagues to respond, you just go look at the webpage. So I'm pretty sure, like when I did the NSFARI, I just pulled research off the CU and Wyoming webpage. So, but be careful about that because they are getting pretty strict about being able to report what science and research was actually enabled by proposals. So they'll back up your proposals. But this proposal is coming out soon. It's due in March, and it is good money. And NSF's anxious to get good proposals. You are competing against a number of entities that are going to submit, so they do need to be.
Good. Start early, read a lot, go back and read the instructions over and over. All right. Well, thanks to the panelists.
Thank you. All right, in these couple extra minutes, I think we sometimes do group dinners for those of you new. So Dave's going to pass around a sign-up sheet because he's organizing the dinner tonight. I'm pretty sure you agreed to that. I'll enable that. And when, again, for those of you that aren't privy to Westnet, we have a very rudimentary webpage, and it's not elaborately maintained. We sort of slap stuff up there. We will be moving all of the current agendas over to previous. There's a previous CIO section, a previous Westnet section. So when you go to look for some of these talks, they'll be shifting down. And if links break, let us know. We'll get them fixed. It's something we sort of do in the background. So keep us posted. If somebody else wants to take over maintaining the web and do it fancier, it's all yours. But as long as I'm maintaining it, it's going to be functional. Yeah, functional and order. So, somebody else is us. Eric.
Where are you going to dinner tonight, Dave?
Where you want to
So, we went to Gordon Beers last night. Ziteja is over on Mill Street. We have gone there in the past. That's one option. P.F. Chang's, I called last night. They couldn't handle a large group last night. I don't know that. This night, that's one option. David, there's the other place we go to over by the train track.
Yeah, I always told her to drop off a new one. It's just covered on the backside of the car. It's just.
Yeah, the train track makes sense.
What's on the backside?
Culinary Dropout, they have, yeah, that's the name of the restaurant. They have football and ping pong and that kind of stuff too. It is a small menu, but it's.
All right, so it sounds like maybe Macayo's or
connected to
David's voting for Macayo's. Is that your favorite place?
You can take a lot of people.
It's a little bit further walk, but it'll be good for you after all this fine food. Since you didn't have a vegetarian option and work up that meat fat. Eric, you good?
I think so. Maybe. We caught up. All right. All right. So Google Hangouts has a 3-second latency when you log into VPN and figure out you're now coming from a different part of the country. Not bad, really, when you think about it. That's actually kind of miraculous. You know? We live in an age of wonders. All right. So first of all, I'll start with an apology. I'm not the best person to be presenting this. I wanted to get my technical staff member who actually wrote, developed, and manages most of this to do it, but he has fallen ill. 'Tis the season, and it's a convenient excuse to get out of the presentation. I don't really know. No, I'm sure. So, want to talk about a couple things. How Utah State University is approaching IP address management a little bit, and then talk about a couple of security visualizer tools that we use. Both of these tools are all custom developed, or the 3 tools I'll show you very briefly today are all custom developed. They are all open sourced with the code released. Of course,
being really crappy software developments, and software developers at Utah State University, and I mean that with all love, but software development is hard stuff to get right. And we do software development in more of the hobbyist hacker form of software development. Good idea, hey, let's do this, and someone's interested and excited, and they pull it off. But of course, it's difficult to maintain, and there's risks, and the software development life cycle is not a simple thing. So we do have those risks. So at Utah State University, when you connect to a network, we branded our network. It's called Blue Zone. This is the portal that you see: students, faculty, and staff, sponsored access, which is code, and guest access. So guest access, you just click that, and you're behind NAT, routed outside of our network and back in, just free and open, but bandwidth limited, with port restrictions to meet guest requirements. No credentials required for this option. These two connect into, I guess you could say, the production, unlimited, unfiltered network at Utah State University. Just VLAN placements, depending on which buttons you push. Sponsored access allows you access to it for a period of time, hours, weeks, days, up to 3 months, say for a visiting faculty member. If we don't want to give them a university a credential in order to do that, anyone can hand out a sponsored access password. So anybody with a university ID, student, faculty, or staff member can generate a sponsored access. So if a student wants to generate one for a parent coming up because they want to do more than what the guest network allows, they can do that.
How many can they sponsor?
Sorry?
How many can they sponsor?
1 million. How many? Or I mean, how many do sponsor, or how
many can one person sponsor?
I don't believe we have a limit. So if you'd like to set up a private business, give IT a 10% kickback. It's all clear. No, I really don't think that we have a limit on that. And that was a conscious decision because with the A number, that guest access code is linked to the person who issued it. And so rather than issue a bunch of laws and rules up front, hey, if there's a case where we find it being abused, we're going to be able to tell, and we'll be able to go back to the person who created those codes and have a private talk, in the back office. Part of this is identity management and identification around security, not just the provisioning of IP addresses.
Do folks have to register every time they get on?
No, but good question. So Utah State University requires every device to do this registration once every 365 days. Once a year. Forced. Everything. Even servers. Even what?
Xbox.
Sorry?
Xbox.
Xboxes, even Xboxes. I thought you said Daxboxes. We got rid of those. Yeah, all of them require re-registration within a year. Period. A couple of reasons why we chose to do that is because the timely accuracy-ness of our data, meaning mapping a managing, owning human to a physical device, is the core of a lot of our security and education practice at Utah State University. If we don't do that, there is no question that if in a couple years the user data mapped to a device we've got to find the contact for is just gone. And there was a little bit of pushback on servers. It's like, this is terrible because If that thing flips, the service will go down. Yep. And so you better make sure that once a year, since you're the owner of the service, you get in and make sure that's re-registered. And so this is the front end for for non-technical end users, but we also have a back end to help manage that renewal process in bulk and in different categories to make it easy. The system triggers notifications via email, text, or whatever people want to provide well ahead of the renewal date. So
you must have exceptions though.
What do you mean?
So managed ports on switches, IP cameras, building automation systems that can't plug in.
If they receive an IP address,
They don't have access screens or keyboards.
but you still have to register the MAC address. You don't do it through the web browser. You do it through an administrative back end, enter them in. Yeah, my network team has to renew. And they can do it in bulk based on groups of network devices. We don't have to go over to 830 switch and switches and renew them. So now, actually, we don't have exceptions to this rule. It's hard and fast access management for this.
So you look up your registered devices. This is like by your ID. You can see what devices are registered to.
Yeah. So these are the ones that are registered to me personally. The expiration date and description. If I want to register a new computer on the network, I click on that. It scrapes the MAC address so that end users don't have to actually populate that. Of course, it says we were unable to determine your MAC address due to the situation we're in here. If you're on campus, it does do that. We allow students to pick their own host name. It'll auto-assign one based on their A number that doesn't exist in DNS. And they can choose a subdomain, mobile or Go or other areas. For departmental IT admins, they're assigned the DNS zones that we've allowed them to manage. Because we want to create this as very, very distributed, so that departmental IT can go out and say, so I own engineering.usu.edu and computerscience.engineering.usu.edu, and we can assign multiple admins, owners over certain domains, so that they can get more options than, say, a student general public to assign or manage to theirs. In here, you can select an expiration. And, we're watching the Google feeds here, so it's a little 365 days, 1 day, 7 days, 14 days, 30 days, or 180 days.
Yeah, you can drop one out. Like you can go in and say, I no longer have this device. I can remove that with manually.
Right, and so on any one of these, I can delete, renew, or edit the host name or DNS name. Students are actually getting pretty good with this, so that they can have their own DNS entries to their own illegal streaming servers and such on campus. So they're widely accessible.
Do you have any issues with the choice of host name?
What prevented us from allowing?
So, you know what? Again, I'm going to go back to the same concept. Anything you do is linked to your student record. You want to write something terribly offensive in a host name and then publish that in a flyer? IT will help you. But you will be reported to, the Vice President for Student Services and go through standard pieces, because, you can't, you could do something illegal, but I'm not going to, you can do something that's, that's not tasteful, but if you get reported, go behave better. And we've had great success in managing by exception and public shaming with that.
I may have missed it, but is this a homegrown application?
Absolutely homegrown.
How much does it cost?
$1. It's open source, so it's free.
Is it a NetReg variant?
Sorry?
Is it a NetReg variant?
I'll pull up the technical diagram that shows, because we're using a lot of open source behind it to manage the DNS. And the Postgres backend database, and we programmed all the front ends to do it. But we're using a consortium of open source developed and supported backends integrated together to produce this.
Okay, so the policy has to be registered every 365 days.
Maximum, but you can choose shorter pieces, yes.
What happens if you get to 366?
So at 366, the device registration expires. The next time you receive your DHCP lease, you're going to get a non-routable IP address that forces you back to that portal of 3 choices.
So there's enforcement.
Absolutely. Yeah, and there's notification before that occurs. We don't want to surprise anybody. But yeah. So this helps us tie people to computers, helps us then tie accountability to devices. Forcing registration keeps that up to date. The front end, notice you can't pick your own IP address, you can't say static or dynamic. There's all sorts of things that back-end IT administrators in their departments will need to do that your common student end user will not. In that sense. And so we have a back-end, OpenIPAM. The project is called OpenIPAM. And right there it says powered by OpenIPAM. And it's we've just got it listed under a Google just under our Google Codes site here. In big top words, it's unsupported. We support it for USU, but anybody else does it, you know, best of luck to you there. But the
Is the IPv6 enabled?
It is. Yes, it is. And multiple VLANs and MAC address-based authentication to place them in and to enforce this. So this is how we enforce PCI compliance and PCI VLAN through MAC address authentication. This is how, let's see. Log in here.
Eric.
Yes.
How long will you allow your sponsored account or a sponsored machine on the network?
Up to 3 months by popular demand from those who are bringing in, say, faculty who may stay for a, for a chunk or a semester.
So a guest can choose that for whoever.
Right, a student can say, you know what, I'm going to let this MAC address come in for 3 months and have unfiltered, unlimited bandwidth, regular network access to the basic university wide open VLAN, and cool. But that activity is always traceable back to someone with logged responsibility for doing that, and that is so much more effective than a policy 7 pages deep in an HR manual. So,
do they have to sign some acceptable use, or do you give them at least say, you just follow the rules, some check marks or anything?
Yeah, there are check marks if they've never registered a device before, before that does that. Although there's been a lot of debate about that. And in fact, I believe we just recently took it out because you don't have to agree to the acceptable use requirement if you're already a student and have signed the admission papers agreeing to all university policies and student code. And so to have to say, well, we better make sure you review and from a paperwork standpoint, we had a lot of debate, and I believe we just recently took that off.
So it depends on your lawyer on your campus.
Yeah, it does. And again, our philosophy is we'll deal with this on an exception basis. If you screw up or we flag you because your computer got hacked or something and we force you through a re-education camp, it's nicer than that. At that point, you will get the training and you'll pay attention because that's how you get out of paying a $50 fee. You want some training, we're nice guys, we'll help you out, and you don't have to pay a $50 reconnect fee if we disconnect you administratively. Or, you don't want to go through the training? Great, $50 the first time, 50% off if we like you there is sort of this nice guy discount because you find that psychologically effective. And then the second disconnect, it's like $100. The third disconnect, it's $250. Report to the student VP office and formal, re-education training.
So how much revenue you generate?
Not much.
You want them to know.
Not much.
Yeah, it's revenue generating.
Yeah, not much. And we use the system to enforce to enforce. When we disable someone on the back end, it adds things automatically to a wiki with disabled reasons that the service desk can see. So they got all the details why, that's linked to a knowledge base in ServiceNow that goes through the procedures. So anytime anybody calls and says, "Oh, I suddenly got disconnected," they'll just link their MAC address. It'll pop up in the disabled list and say why it occurred, and here are the options, and here's how we can help you not have this situation again. And because we're cool, we're going to cut the price in half. Or because we're cooler, why don't you visit with me next week? Let's have a brief conversation. We won't charge anything. That's sort of an approach. So this is the. And I'm sorry the resolution is not so cool. So this is the back end database, the back end interface for more of the IT type staff. So you can go into hosts or you can go into DNS here. Under hosts, there's show mine or show all, and we're scraping all the data off all the switches for what is ARP data for
table.
Yeah, so you can see when was this last seen, type data, expirations, search tools, last seen. Get into the formal DNS records where you can edit and change the resource records and DNS types. For that, all of this is live and happens in real time. You can edit individual entries, change. Zoom in. Dynamic routable address, dynamic non-routable, static non-routable, static other, static routable. And all these options are based on access control lists and groups in Active Directory. So we know if you're departmental admin, we're looking at attributes to see what zones you can manage in DNS. Not everybody can assign static addresses. Others can, based on where we place them in the trust hierarchy. And then they can only perform these within the assigned zones that they've been given in there to do it. So DHCP groups. These are the areas where we can type things like PCI or server or content filtered, where we can assign one IP or a set of IPs to a certain VLAN using MAC address authentication, so that whenever they receive an IP address, they're in that particular group that receives different services, different security services, different firewalls. So right now we've got wide open. We've got a server-based one that has certain firewall rules applied to that VLAN. We are developing one for content filtered that we're going to actually enable with a drop-down on the end user interface. So that if you're registering a device and you're like, you know what, porn is overrated, let's block it. Choose the content filtered network there, which is a request we get a lot when parents are coming in and they're like, do you have content filtering on your network? And we're like, no. Your student can do whatever, the world is there. It's higher education, right? This makes some parents unhappy. So one of the things, they can do it anyway, but, So we're going to start, providing some choices. So it's like, you know what, you want to do that? Students can opt into a filtered network. Now, of course, they can go in and just change that back to the unfiltered one because we're not going to be the police for them. But we do want to provide the option for those who do want them. So various security zones. Some will be available to end users. Some will be available only to sysadmins with certain roles. We're not going to let anybody register something in, to be placed in the PCI zone. We're also tracking, or have the option to track attributes, a small asset management type system, which we are using largely for our network infrastructure. The drop downs of common switches that we're using as a basic access management. And it can all be done by grouped, full-scale searching. Then you can choose an action, delete selected hosts, add owners on selected hosts. I'm going to assign these to you. Replace owners on selected hosts, remove owners on selected hosts, renew selected hosts, add addresses on selected hosts. So bulk operations to make it easier for back groups. There are other options that I don't have because I'm just the CIO. If my accounts get hacked, it almost doesn't matter because I have rights to nothing at Utah State because I'm not running the systems. So I don't have access to do major things with zones, but I can mess up my own stuff in here. In that sense. So in brief, that's our IP address, MAC address authentication, VLAN, fully distributed IP address management system that we've created. And it works really pretty well. So.
What back-end DHCP servers does it work with? I assume it's rewriting configs and stuff like that.
Yeah, it's doing everything on back-end. What is it, Power DNS on the DNS side? I think that's an open source DNS.
And DHCP?
I'm not sure DHCP.
So it does it through configuration.
There you are. Now, you'll notice one of our problems is the documentation is probably like 5 years old, or 2 or 4. I mean, documentation, we don't do that in IT. Especially for unsupported projects. They're the basis for everything we do at Utah State. So, okay, any last questions on that?
Can you add special DNS records like CNAME?
Absolutely. Full scale, anything you can stick in a resource record, you can do in OpenIPAM either individually or as a group.
You said it was IPv6 compatible. Are you guys doing, what, if anything, are you doing to force people to register as opposed to V6 will just auto-configure and start talking to other people on VLAN or whatever?
I'd have to put you in touch with Eldon Coyle to really get into that. We aren't doing anything with IPv6, but they are completing a rewrite now for the system to be able to handle it. But how they're going to deal with auto-configuration, all this stuff, or what handle really means when you get down to it, I honestly don't know myself. So I have to put you in touch with the developers. Yeah.
How many people do you have working behind the scenes to create this one?
Far too few. If those people get hit by a bus, size of checks I'll be writing the info blocks will just be that big. This is one full-time developer and 2 part-time, well, not part-time. There's 3 full-time people involved. One, it's his job exclusively. The other 2 are backup, operations, and assistants to understand it well enough so if he gets it.
So within those 3 people, is there anyone for DNS or DHCP sysadmin as well?
Yeah, we have sysadmins behind it, to maintain systems.
Position.
But they're really just maintaining the servers, not the applications in them. So the 3 manage the DHCP and the DNS and the open source components that are tied together through this. So, and I can put you in touch with this.
Kelly's going to do a talk soon on managing complexity, and I'm wondering, does this system help your complexity situation, or does it compound it?
My feeling is from an operational standpoint, I find it extremely effective. We can distribute the responsibility out to units safely and securely, and they're responsible for what they do, it instead of all requests having to come through central IT for everything. The simplicity that's enabled by always having someone identified to a device and managing automated MAC address authentication to VLANs, operationally, this is really slick. You know, disabled and security and tracking and mapping people to devices and controlling, but providing trusted access in a distributed nature into the distributed IT units. Boy, it's been great, and so far so good. I'm pretty happy with it. And I receive a lot of compliments from distributed IT about this system.
How long have you been using it?
We've been using it for probably 6 years, but it's seen a lot of improvements in interface changes to reduce the complexity and make it just work.
But what you just said sounds like it depends on where you're looking at the system, the entire environment, whether it makes the complexity less or greater. For some jobs and some positions, it's more complex. For others, like yourself, it's made it a lot easier, less complex.
Now, for the guys who are writing it, is it more complex than just going and buying a solution? Of course it is. But
even the customer, though, he used to just be able to send you an email and you'd do the work. So it's more complex for him. He actually has to do it.
No, not really, because when they send us an email, it would take me 24 hours to get around to it. Any change needed to happen. It wasn't instant and on the fly. No, that's absolutely not the case. That was
the timing is not the same as complexity. What I'm getting at is complexity is a pretty complex issue. And I don't.
You know, I respectfully, I'm going to still disagree. For someone to log into a portal, not have to look up their MAC address, drop down and I want a filtered network, click submit, and bam, they're there, compared to command ifconfig/all, look this up, get it right in the email. Oh, there's a filtered thing. I don't even know what that. Can you do that for me? Oh no, I need to change. I mean. No, I don't think so. I mean, this is built from an end user perspective to be click, register, go, or plus an option to do some really advanced stuff if you need to do that.
And you understand.
And if you want to do those things. So, anyway.
So your help desk doesn't get complaints about it.
What?
So your help desk does not get complaints about it.
Not about the network registration system. No, not. We get complaints.
Notification, you said there's a notification process when they're getting up to expire?
Yes.
Email or
yes. Yep. Is my time up?
No, but I was going to interrupt you while Daryl was making a comment. So for those of you that have been around for a long time, you know Daryl Eschbach. He was, for many, many years, our local host here at ASU, and was very gracious, and things have never been the same since he left. But for those of you who don't know Daryl, he was a long-time employee here in IT, and really, again, one of the founders of Westnet and the early adopters of Westnet. So we owe a lot of debt of gratitude to him, and we invited him to hop in and say hi to us. And so welcome, Daryl.
I was watching online, and I didn't like the Google situation, so I came over to see it live.
Thanks for coming by, Daryl.
Thank you.
All right, so in the last 5 minutes, I'm just going to show a couple other pieces of open source code that we produced for fun and profit, but there's no profit in it. So these are some IP visualizers, and some of you have seen these before. The reason why we did this, now these points were written by the technical person who did it. You know, one, when you just see inflows, stuff scrolling past the screen, they're boring. I mean, the purpose for any visualizer is to give you some new and unique way that your eyes can look at and make a connection that was harder when the data was in a more raw form. In order to look at things differently, visual processing, and hey, management, look how smart I am. That totally works, because the guy who put this together, I look at him and I'm like, dude, you're smart. And it absolutely fosters curiosity. So here's some technical stuff of what's happening here. This is essentially a grid of
Eric, I have a question for you. On this open source stuff, do you guys have any pushback from your whoever?
From our whoever?
Lawyers?
Lawyers? No.
On releasing it back into the open source community?
No, not at all. Now, they're very supportive if we want to try to commercialize this, and they'll help us with that, but if we have no interest, they're like, whatever, go. No, we don't have any problems with it. We've not had any problems. So this is a /16 IPv4 visualizer. Every dot represents one IP address. The color of the dot, green, red, white, or a white X, depends on the type of traffic. UDP, TCP, a white X means it's something that was intended for that client, but our firewalls blocked and threw away, for example. And this is so here's a zoomed in section of what it looks like. You know, TCP, TCP and UDP packets.
Like a source or destination is that IP address that lights it up?
Yeah, just IP address. Yeah, I believe it is.
Either source or destination.
Yep, source or destination on this. Originating and receiving.
Somebody's scanning.
On this. Is there something happening?
The square is filling up. I figured somebody was
busier. Yeah.
Figured somebody was scanning.
So,
never just went down.
So what happens is this okay? Good. So what happens on this screen, and we'll put this up on a big wall, so and you'll be able to see because it happens all the time. People doing port scanning. And you'll just see lights go. Each one of the squares is like what is it, /24. Each one of these squares that represents typically a building or a geography. The larger blocks are wireless. We've got some sections that are darknet. If we see traffic in it, we know it's probing or other areas. So visually, you can just kind of look at it. And so this provides an interesting opportunity for security awareness discussions. So we'll invite the president or the executive council in. We'll put this up on the big screen, and we will know the IP address of the phone in their pocket because we've got A numbers and registration data, and it's right there, really personal, really close to home. And you'll see a scanner start moving across. And we're like, okay, so that's originating from China or Russia, and they're trying to find, now see that little dot right there? See them getting closer and closer. That dot represents the phone in your pocket. Closer, closer, closer. Bam! Oh, did you feel that? That was somebody from China in your pants. They are shocked. I mean, we're generally a little bit more diplomatic when the president's there, but I mean, when you see how much of that scanning just shows, and it's typically with white X's, if we block it, so we're blocking that already, and how often this happens in showing statistics. It does become a wow show tool to let people know that this is real. And we're watching it, and these are some of the things that we're doing to protect. Now, this guy, being smart, found a way, just out of kicks, he can upload a GIF or a JPEG image and then generate traffic out to the right computers in order to reproduce the JPEG by real-time network traffic. So you'll see it pop up here. A Hitchhiker's Guide to the Galaxy GIF that he uses by setting the right type of TCP, UDP, or blocked traffic. I went back too far, didn't I? Oh yeah, we're close. It's like 39:40, so. It'll pop up. That's not it. That was a fast scan there. There it goes. By touching all the computers all over campus with the right with the right layer of traffic to produce the image.
So wait, should we figure that out? New messages?
What? Yes, you seriously can. You absolutely can. There is no question at all. And the code is open source, so everyone send.
I just need to know where your network boundary is.
Yeah. Yeah, no, that's exactly right.
Top to bottom.
Yeah, right. Yeah, exactly. You could send us University of Utah logos, or worse, we'll have to put content filtering on it.
Yeah, what you actually like to do.
So Dave, somebody needs to go in and take a tour, give a little feedback so we know how the grid works, and then.
I know the guy who wrote it.
Yeah.
Have you been able to spot APTs by using this?
I don't even know what that is. So.
Advanced persistent threat. So those would be people who are trying to get in over a long period of time.
I mean, if you can't see a pattern in the traffic there, I mean, probably not. I mean, if they're careful with it.
Is that information recorded and then patterns are looked for over time, or is it just real time?
This is just real time. This is just real time. Although he could replay flow data if he's got it. You know, if he's got it in there. Last thing I'll show you is an organic IP visualizer, which draws traffic as blobs traveling between hosts. So in this case, instead of monitoring all traffic based on TCP, UDP, or blocked at the firewall, things like that, we're going to say, let's look at port 25, SMTP, or something like that. And we're going to look at all the SMTP traffic on campus. And so what it will do, this is not going to show it well, but the main IP you're looking at, or the most communicative IP address, right there, floats to the top. So the one that's doing the most, say, port 25 traffic, floats to the top. And then the magnitude of the lasers and phasers going towards it shows the size of the packets and the frequency of the packets from all the other hosts communicating with it. And this updates in real time. So if that one suddenly isn't talking port 25 much and another one kind of floats to the surface with all of its communicators, that will happen. And you can link this to any one of, to any IP port to monitor on a surface level who the big talkers are to and from. As it's being visualized, and it's too dark and too low resolution here to see, as another tool that he's done. Written in C, C++, not for the faint of heart. It's available at Google GitHub, USU Security, you'll find it. Debbie Tech is available for those. So, one more time, gotta go. Thanks.
Do you have other institutions using this?
All right, Kelly's.
Or are you
going to
guys just the
present
only
on
one? Nobody has
managing
sort of taken it
complexity.
and adopted it?
I don't think it is.
Like I'm just sort of looking at, yeah.
Documentation's out of date and stuff and all that.
Yeah. Interesting. Thanks. Thanks, Eric.
Yeah, really, that's a great idea. Kelly.
The executive director of Westnet.
Yes. Yes. Brilliant.
She asked you to. I haven't said no yet. Yes. Okay. So I think it is a great privilege to be able to speak to you. I've been doing this for a long time, and I've been very pleased with the interactions we've had, and I've enjoyed very much just being part of this group.
Mention.
As you can see, I'm no longer part of BYU. As an active employee, I've retired. Daryl, I joined your group. Joined the crowd. Yeah. When I signed up for Westnet, I thought my organization would be called Kelly C. McDonald Associates. By the time I got to incorporation time, I'm the only member, so I found Kelly C. McDonald LLC. And so, haven't got a lot to talk about with as far as BYU is concerned, but something with regard to complexity, which I've talked about a lot with this group. So, to get started, let me just say some things. I've kind of been the Westnet go-to guy. Now, what I mean by that is that whenever there was a blank spot on the agenda, Kelly can be counted on to give a talk on complexity. And so some of you will remember the June 17, 2009 complexity. Or perhaps the June 13, 2013. We actually matched the complexity with a different title. But it was complexity much the same. And then, of course, last year's, a year ago here in Tucson, Managing Complexity Revisited. And I actually went back and looked at the slides from this and compared it to 2009, and they're actually pretty close. It's almost like it was the same presentation, kind of just refocused with a different background. So, as as a retiree, I feel like there's something that I need to probably pass on to someone else. I think we need a new go-to guy. I'm recommending Todd Bear. Those are good. Todd's had an office next to mine for a while, and we've had many complexity discussions. Todd has popped in and say, "This seems like there's complexities at the root of this." And I'd say, "Yes, Todd." Learn from your Westnet discussion. Todd lives and breathes complexity every day. He's got a large organization that deals with infrastructure at BYU. It's large, it's complex, and he just deals with it all the time. But there actually is one other qualification, and that's that he has access to my PowerPoint, and he could replay them every 3 or 4 years. So in any case, I've appreciated being able to come and talk about this topic. I think it actually was before 2009. That's the only one I have a slide for. I think I actually started in the early 2000s. talking about this topic from time to time. And I'd like to kind of switch gears just a little bit and introduce you to Donald Norman, if you don't know him already. He's an author. He's written these and other books. Sure, these are the ones I've read. And almost every one of them have very much a similar theme, a theme on complexity and how we deal with it in our daily life, in our everyday life. And I suggest that you take a look at these books if you're interested in this topic further, because he's a great tutor in managing complexity, reducing complexity, especially in design. He's just a great author in that realm. And more specifically, his latest book, Living with Complexity, from which I took the title of this presentation. And a couple of themes I'd like to just introduce you to from his book. Why complexity is necessary, and simplicity is in the mind. Now, the first topic, complexity is necessary, is kind of unusual because we've been talking for years now in Westnet about how we reduce, even eliminate complexity. And Mr. Norman's contention is, his thesis is that you can't and you shouldn't, because complexity is part of life. Why is complexity necessary? Because life is complex. Now, every one of you that flew here, came in a plane, probably had that kind of a cockpit in it. And if you take a good look at that, you can see that's a little bit more complex than the one in your vehicle that you drive. And you think to yourself, how could anyone get any understanding of that? But yet, millions of miles are flown per day in planes, complex vehicles, because there's not really anything, these have already been reduced to the level of complexity necessary to keep them safe and to keep them in the air. And so somehow the mind has got to be able to adapt to this complexity in such a way that it can deal with it in a straightforward fashion. So our lives are complex. Everything about us is complex. And we have to have to learn to live with it. I think that's the thing here, living with complexity. We really can't reduce it in any significant extent. Now, that doesn't mean we can't optimize as best we should. We can, and we should do that. If we look at a problem and try and find some alternate solutions to the problems, we have to select the solution that has the necessary level of complexity, right? I think that's part of our job. That's what we do every day. But we can't get away from it completely. And those that say we need to eliminate complexity from our lives just aren't grasping this concept. Now, only that, but our lives are complex. Our own lives are complex.
That's Al Gore.
That is Al Gore. This is Al Gore's office. Right? And this is the example that Donald Norman used, but he could have taken a picture in my office. It probably wouldn't have looked a whole lot different than that, and probably many of yours as well. Because your lives are complex, right? And we're interrupted minute by minute from one level of task to another, and we learn to deal with it, right? I'm certain that if I walked into Mr. Gore's office and said, "Could you find me that report on green nuclear weapons?"
That's the original design of the internet.
You would reach down, that's right, you would find that. You'd reach down here somewhere, and there it would be. I could do it in my office, and I'm sure you can do it in yours, right? You have created mechanisms to help you deal with the complexities of your life. And so, some of the things that surround us a little more directly. Here's a vSphere command to configure iSCSI. Well, that's about the level of detail that I know, right? But some people in Todd's group know exactly what this means. Each one of these options here have a whole page of parameters to them. I can't remember exactly how many pages this went on in the manual that I extracted this from. But it's complex, at least for me it was. Yet Todd's staff does this, they deal with this every day. Right? They figured out a way to live with complexity in their particular part of life. And it's all around us. It surrounds us. Even basketball is extremely complex. Now, Michelle has been trying to tell me that basketball is simple. So I said, okay, I'll see if I can prove that. I went to the NCAA rule book, and here are the rules on traveling. Okay? Just take a look at this, right? Okay, traveling is illegal movement of 1 foot or both feet beyond the limits outlined in this article in any direction while holding a light ball in one playing court. Okay, well, okay, I can get that part. You have to have a pivot foot, right? Pivot is a legal movement in which a player is holding a live ball in the playing court, steps once or more, and once in any direction with the same foot. But you can't move your pivot foot. Is that right? Is that the rule? So it says something like this. While standing with both feet on the floor, the movement of one foot is lifted, the other foot becomes a pivot. While moving, if one foot is touching the floor, that foot becomes a pivot foot. If both feet are on the floor, the player lands on both feet simultaneously. The moment one foot is lifted, the other one becomes a pivot foot. Right? If both feet are off the floor and the player lands on one foot, then that foot becomes a pivot foot. If the player jumps off that foot, it comes to a stop, landing on both feet simultaneously, then neither foot is a pivot. So what happens when a coach yells, "Don't travel"? What's going through the mind of the player?
All of us, I'm sure.
Right? They all stop. What happens? You even think about it. You found a way to deal with even that complexity. And so I would submit as my final complexity talk to Westnet that we learn to live with it. Right? We learn to live with complexity, the complex nature of our lives. So that takes us to thesis 2 of Donald Norman, which is simplicity is in the mind. Okay? We deal with complexity by simplifying it up here, not out there in the complex world. And so he states this, these are quotes. Simplicity is the mental state, highly coupled with understanding, something that is perceived as simple. Excuse me, simplicity is a mental state, highly coupled with understanding something as perceived as simple when its actions, options, and appearance matches the person's conceptual model. And that's key, right? The person's conceptual model. If we have a conceptual model of how it works, it is simple to us, okay? That's why a pilot can fly the plane, right? They have developed a conceptual model of that cockpit in such a way that it becomes simple to them. Al Gore has that in his office. I have it in mine. You have it in yours. That somehow you have constructed a conceptual model that makes it simple to you. Okay? So here is the definition of a conceptual model. These are quotes from Donald Norman. A conceptual model is the underlying belief structure held by a person about how something works. That doesn't have to be correct, right? As long as it defines for them how to deal with it, and it works for them, it simplifies it in their mind. So a child might think, in dealing with a computer system, that when I delete a file, the conceptual model might be that some dragon comes out and eats it up and it disappears. Well, we know that doesn't happen in reality, but that's the conceptual model, and it works for them, right? When you say, delete that file, they use their conceptual model to essentially remove it. And whether a dragon ate it or not, doesn't matter, okay? That's the point of simplicity is in the mind. So what makes something simple or complex? It's not the number of dials or controls. It's whether the person understanding the device has a good conceptual model of how it works. So let me give you some examples. Let's see, Todd, do you recognize the picture?
That's in 3006.
It is. It's in our conference room. And light switches in our conference room. What's the conceptual model that most of us have when you have a bank of light switches and a banks of lights? Where does this one turn on? This one, right? Where does that one turn on?
Yeah.
That one, okay? Somehow, our electrician must have been a low bidder. Didn't do this right. And even more so, the switch that's on the other side of the room isn't the same. So every time you go in, you have to use all the switches to finally figure out which light to turn on or turn off.
Every time. How long you been there? Every time for 40 years?
It's been 5 years in this building.
Oh.
Hasn't raised to the level of priority yet, I guess.
And you didn't bring a screwdriver and fix it yourself.
This is what drove him to retire.
So in any case, something that seems like a simple conceptual model can be made complex, right? And vice versa, right? The point is this, that this could be 100 switches, but if it followed a conceptual model, it would be easy. Now, you got a whole bunch of them, you'd have to kind of figure, well, I always get close to it in the center. But still, a conceptual model works. Okay, here's another one. This is, whoa, what happened? PowerPoint inherited problem, needs to close. So my conceptual model all of a sudden didn't work, and in fact, I don't want to send this to Microsoft. Help me, Alex.
Your conceptual model is that Alex will fix it.
This is the simple issue here, right? But we have something in that slide that it doesn't like. That's my conceptual model of PowerPoint. Yeah, we'll get there. It crashes again. If it crashes again, it's validated, right? That there's something wrong with that slide. All right, here we go. All right, something else. Okay, so this is a model for the Java virtual machine. It was a great idea, that we could actually create a cohesive model across almost any kind of hardware. So I could write Java code, and it would run on my watch, or it would run on the largest supercomputer. And I think it was a breakthrough idea. It was not new. I mean, this is an idea from the 1950s. That we had something like this, and pragmatically, it has revolutionized the world. But all of you know it's as tough as beans to deal with. Or if you get the right version of Java on your machine, bothers the heck out of it. But in any case, that's a conceptual model for all of those universe of people above here that is writing, developing code. This is a conceptual model that they deal with, and somebody down here creates this engine that will run on whatever machine that they want to have it run on. So another conceptual model. Here's another one. We deal with this every day. x86 abstraction layer, VMware, and other hypervisors create this this conceptual model of these services that are provided by very different equipment below, and it allows us to create these abstractions here we call virtual machines. Virtually every application we either buy or deliver or create ourselves, develop ourselves, has this application abstraction layer on top of it. And we think about applications as that screen of functionality. Okay, that ends up becoming this conceptual model of the person that uses it. My wife is not particularly technically adept, but in her work she had these screens that she worked with, and that was her conceptual model of the work she did, and she was very effective at it. Right? And so that's the way the world works with regard to simplicity. It's in the mind. So what does this have to do with Westnet? This is where we depart from Donald Norman. Now, I have to tell my former staff that these come from the first 2 chapters of his book. That doesn't mean that I haven't read the whole book. There's this running joke about me around the organization that I only read the first couple of chapters of any book. And that's not true. I read all of Donald Norman's books. But generally, the good ideas are found in the first 2 or 3 chapters of any book. That's been my experience. I once held a record at BYU in a given year. I was checking out more books than any other person in the BYU library. And I thought it was great accolades, but no one ever asked me, did you read the books? I couldn't say yes. I typically read about 1 to 10. Because I go get the ideas from the first couple of chapters. These are the first couple of chapters from Donald Norman's book, but I would recommend to you that you read his old book. It's a great read, and I'd point you to it. But what does this mean with Westnet? Life is complex, and simplicity is in the mind. What does it mean to us in our careers in Westnet? Any thoughts? Someone said something? Yes.
Map it to the human need and expectation, like your light switches. You got to think about how a human would approach things and then build things to achieve that.
All right.
Pay attention to
We
the
create models all the time, don't we? In our work, one of the biggest things we do is create models for others to understand what we do, right? And we call them architectures. Right? Architectures are just conceptual models. And so, well, that picture came out great. I don't know what happened to that one. All right. Sorry, you can't read that very well. It looks a lot better on my screen. So I'm going to have to describe this. So Todd is now the managing director of infrastructure, and one of the things I did with it for him the last couple of months is try to develop some architectures to help convey the complexity of the infrastructure at BYU. So I'm going to kind of tell you what these are, I guess, but it seems to me from the things we do that we have 3 main infrastructures. We have one called the campus AV infrastructure, campus network infrastructure, and the campus server and storage infrastructure. And they are connected to the services that use them above this infrastructure line. And we believe that we need an infrastructure management system below it. And something very new that we want to start doing is providing an infrastructure API so that systems and services could control the infrastructure in some way, okay? So that's a little 1-page diagram. There's only, what's 10, I guess, elements on it. Can you get from that a kind of a highest level view of what our infrastructure is like? Kind of grasp it, can't you? I mean, it, in a very simple picture, reduces complexity in your mind. It creates simplicity, right?
So Kelly, on
Sure.
that point though, there's 10 elements on that box, but this is like our 8th revision of that diagram or something like that. I mean, these 10 boxes have changed locations, we've changed models a number of times to get even to this point.
That's true. I'm not saying it isn't easy to create them, but it creates a simplicity. I mean, its goal is to create some simplicity in the mind of the receiver, right? If you will, right? You've handed this out to your staff. They're saying, yeah, okay, I can kind of grasp that. That's what the infrastructure is, it seems like to me. I think we can tell others about it. We can even tell administrators on campus. This is kind of the scope of the infrastructure of BYU, right? So we went down a level. It's a little more readable. This is a different way of drawing the network domain. Now, this is, if we went back and looked at this earlier one, this is that center bubble right there, okay? And this is inside that center bubble is it's a layered network. So we've been talking about layers for a long time, but these are different kind of layers, right? These are no longer OSI-driven model layers. These are layers because of the way that people inside of Todd's organization do their work. Right? So here's device attachment and aggregation layer. That's the part where we hook things together into VLAN, right? We either connect them physically or through wireless, and we aggregate them. We attach devices and aggregate them. Then we have another layer of connectivity routing. So we're hooking these aggregation layers together through routing, and we regulate routing. That's where firewalling occurs. And for the most part, those 3 layers kind of describe the network in a very high-level way, right? It's a simple conceptual model that allows us to communicate to others what the network is, rather than saying, well, this is layer 2, layer 3, layer 6, which doesn't really exist in TCP IP, or whatever, okay? Next level. There's always been that big amorphous bubble here at the bottom called the infrastructure management system. Well, here's a picture of that. I do have to read this. There's the domains up there. These are called status and control systems, which which control that either gets data from or control the domain. I wish we could show you the pictures, but I don't know why that looks so bad. And this is a, I can't remember what this one is. I have to read that one over here again. I can't even read it here. So, when I send tomorrow, it will be readable. I think this is called the Service and Reporting System. This is called the Autonomic Services System. And they control these status and control systems in such a way that we either get data from the domains or we pass control information to them. See this line right there that should have gone into there? There's our infrastructure API. Okay. So thus, architecture is developing conceptual models that solve real problems, strip away the unnecessary, build greater understanding, and maintain, even improve, conceptual integrity. And that's the other word I want to just talk about a bit today. Conceptual integrity is the principle that anywhere you look in your system, you can tell the design of the component is part of a larger design. Okay? Now, if I go back quickly to these diagrams, you look at that one, you look at that one, you look at that one. Can you find one element of conceptual integrity in those three?
Domains?
There's probably a lot of them, but there's one of them right there. It's the infrastructure API, right? That's conceptual integrity. We've decided that that's an important feature of our overall architecture, and so we maintain conceptual integrity by keeping it always in our model. Okay? That's what conceptual integrity is. So I want to get to this. First of all, I believe that architecture, in the context we've talked about it today, is the basis for problem solving. And we have a simple method to do this. We develop a problem context. We create a solution vision. That's an overall vision. We create an approach that accomplishes that vision. And then we tell what the results of it's going to be. That's the essence of an architecture for us. And so we want to do this in 1 or 2 pages, and then we submit it for funding consideration. That's what we believe is the true value of a conceptual model in helping us to run the architecture in an implementation at BYU. Okay? So I'd like to spend just 5 minutes. Can I have just a few minutes here again? Okay? Doing this. And Todd, as the go-to guy, is going to take notes.
Oh, I just start taking notes now.
No, right now. Right now, Todd. Thinking about this context that we talked about, what's your viewpoint of architecture? What's Westnet's viewpoint of architecture? And how do you manage it in your organization? My guess is that the word architect or architecture is widely defined. What is it to you? Input.
Well, the University of Utah really struggles with having a disciplined architecture approach. I mean, it's if you ask 5 different people in our organization, I think you would get 5 different answers right now, because we don't have a cohesive architecture.
Don't have conceptual integrity is probably what you're saying, right?
Yeah, I mean, we have an architect team on the hospital side that, I mean, they talk to the TOGAF model or whatever you want to talk about on their side, but then you have, just people around campus that think, an architect is almost an engineer. They blend the two. I mean, I'll be honest, I have a network that's been engineered, not architected. That's in real, I'm being very, very transparent here. You engineer things or you architect them. And an architect, like you say, takes and looks at a bigger picture and makes a conceptual model and works through the model to an end result. Whereas when you engineer something, you say, oh, I can do that. I can put this ACL here, I can do this, I can do that, and you end up with firewalls, you end up with the ACLs, you end up with 50 different things all doing the same thing, and there's no architecture, no conceptual integrity to it. And so it's, I think, we in IT are really good at engineering things because we like to play with toys. But a lot of times we don't take the time and the mental discipline to architect.
Good. All right. Other comments? Yes.
So, kind of to that point, I mean, if you were to look at architectures that people put out, I used to be very sort of prescriptive in architectures, right? This is how we're going to go solve problems. It wasn't until I started working with people who had a broader vision that it was architectures are prescriptive, or not prescriptive, but descriptive, right? And so when you force yourself to not try to solve problems, but to define problem sets in architectures and what tools you might use to do this without actually specifying that, it became very liberating because now more things became possible than just what you thought solutions should be. But still, when I do hear people talk about architecture, almost always, at least in my peer group, it's a very prescriptive, detailed, this is how we're solving these problems, not necessarily these are some of the things, some of the ways that you could solve these problems, or some of the guidelines that you want to stick to.
So one of the things about solution vision is that it's typically dominated by a bunch of principles, a bunch of guiding principles, architectural guiding principles that we're going to adhere to, right? The approach is really pretty high level. Approach is in an architecture is typically, it might be the very beginning of an engineering process for some major aspect of the problems, of the solution, right? So there's just this effort of making sure that in our vision, we've got the right principles. Okay, other concepts, yes?
I think I've found in our organization, a lot of the architecture is there, but not documented.
Okay.
And the tools that we built up, like our IPAM tool, has a lot of that baked into it, so that it can take time using the tools, running up against things that will work, won't work, and you discover there was a design here, there was an architecture, it wasn't documented.
Yeah, clearly, someone had that conceptual model somewhere. They just didn't put it down so others could understand it, right?
Right.
The maximum is true. A picture's worth 1,000 words, right? Others, yes?
I kind of think that architecture or putting your ideas on paper and a drawing especially really has to make somebody really put those thoughts together, and you see flaws or the good points of things that come out.
Very cool, because that's Todd's point, right? When we started, that was probably what, version 10 of that diagram? Pretty simple diagram. And it took the input of a bunch of minds in putting their version of the conceptual model that we then came to consensus on before we got one that was reasonably set. Very good. Others?
So is a picture always an architecture though? I would argue no. I mean, I can show you a schematic of our network. I can show you the exact, and there's no architect. I mean, you know what I'm saying? Just because you can draw lines between things and you can document something, that doesn't necessarily mean there was an architecture. And that's, because I have Visios of my entire network, and I know exactly where everything connects in the sense of a engineering diagram.
That's more of an engineering diagram, right? In fact, but it's not an architecture. We've had a conversation that once you put a vendor's name on it, all of a sudden it's no longer an architecture, right? Architecture is technology agnostic. We're talking about concepts, right? Whether or not it's Juniper or Cisco that solve it for you, that turns it into an engineering diagram.
Yes. I agree with that. So when you see these models and these pictures, and people like to use those as representations of their architecture, it gives you no context as to why.
That's right.
Right.
That's right.
There's no why behind that at all.
You have to match the picture with the principles, and more importantly, with the problem context that you're solving. Right. That is number one. Yes.
Yeah, the organizing principles are really what are the basis of your architecture. You're going to process something once. You're going to move data from here to there once. You're going to minimize your processing times in all cases. I mean, those are.
That's your vision. That's your vision, right? You got this problem context that you defined well, and then you create your vision, and then the approach. Right? Yes, Scott.
So I think we're in kind of the same boat as everybody else. We go through these processes, but we don't have a formal means of, or a disciplined approach to these, and that's a really good idea. And having seen this now, in hindsight, it's something that.
So I suggest, and I'm going to say this now as my parting shot at Westnet, I suggest that we have an architecture subgroup that reports every meeting on progress in helping us to define better what the architectural stance of Westnet is. What makes a good architecture? Give me some examples. I mean, it's like the, what are you doing about it type of a thing. That maybe we need to have this is an architecture for this problem that we have to solve. Maybe in some sense, maybe we morph what are you doing about it into that kind of a.
I think you need to point over to the
Todd, how are you doing? All right, I'm out of time.
There's a couple words.
Oh, okay, sorry. So let's get Daryl on here. Okay.
Just to throw a little monkey wrench in the whole discussion, Kelly. One of the problems with architectures is they stifle development and new ideas. And because if you're going to have an architecture, you're going to think out the solution to the problem. Now you're going to define how you're going to get there, and now you're going to implement it. And then you say, yeah, but you know, if we just added this other little feature over here to take care of a new problem, oh, no, it's an extension of the problem, not new. And so there's a real nasty trade-off when you want to set things in stone.
Yeah.
And I'll use IBM and Microsoft as examples. IBM architecture lasted from '63 still. Microsoft, I hate Windows 8. I really do. And it's not the same as Windows 2000.
Yeah. Well, the only answer I can give to that is it really is a balance.
Yes,
right?
that's really the point I was trying to make.
If we start using architectures too much as clubs,
right,
then I think we get to the point where you're talking about. Yes.
I kind of feel like the acid test of an architecture is if you communicate just the architecture to another set of engineers, they'll implement something you would recognize as consistent from just that information.
Well, in some sense, it's communicating both ways, right? It's communicating to those that have the problem. This is our approach to the solution, right? And it communicates to engineers, stay within these constraints, right, generally. So that's a two-way communication tool. Any other comments? All right, let me just wrap up with a couple of things. So here's my thoughts on Westnet. This has been one of the highlights of my career. I've enjoyed the interaction with right-minded people. And the term right-minded, I think, coined by Pat Burns, was that that's what Westnet is all about, is being right-minded. And I have enjoyed very much. It's been a highlight in my career to be able to come and interact with you and your predecessors. After all these years, I don't remember the problems anymore, but I do remember the people. And I remember how we collaborated in a very fulfilling way, both to me and I hope to others. I came to regularly ask this question to my staff. What would the members of Westnet think? We did that just the other day. Michelle had a question about some product, and she put out a question on the Westnet list, and she had half a dozen responses. In fact, some folks said, hey, we've used that tool. Come and take a look at it. We'll tell you all about it. And that's what right-minded thinking is, in my opinion. Every time I've attended here, I took away one or two nuggets to try out at home. If you look at my book there where I've been making notes, even this week there have been 2 or 3 that I put a star by, which I'm going to say, Todd, Michelle, Brad, take a look at this idea. I think it's worth taking a look at. And I guess I hope that I've been helpful to you. I enjoy collaborating with many of you on IP telephony. it's probably the catalyst that started me talking to you. You know, I was pretty quiet, pretty silent my first few years at Westnet, and it wasn't until all of a sudden people started saying, "You're doing what on the network?"
Do you thank Eric Denham for that?
No, actually, I think actually IP telephony was my idea. And luckily, in retrospect, it wasn't the wrong time. It was the right time. Okay. I helped Chad fix his garage. We actually weren't in the Westnet meeting. We're actually in an IPv6 Rocky Mountain IPv6 forum meeting. Because of our affinity, we sat next to each other, and Chad was telling me about his garage door and says, "I just had that problem. This is what I did to fix it," and it worked. It fixed it. Great. Cindy, she and I had a few sessions on student email, and I hope that that was useful to you.
It was useful. We're moving in a different direction now, but it was
That's
useful.
all right. And I had dozens of similar memories, and I appreciate very much what you have done for me. I moved out of my office a couple weeks ago on BYU campus, which I will show you in my lightning talk. And I moved into my home office, and one of the walls has my treasured possession. Which is this plaque that you gave me last time, recognizing my participation in Westnet over many years. And it will occupy a sacred place in my home and in my thoughts. And that end, thank you very much.
Kelly's indicating that he's not going to come back, but we have had many suggestions that we create a special category
For emeritus.
for an emeritus member. Not everybody would qualify, and I get to judge, but
That's farther in our true form.
Yeah, unless Kelly wants to start running this, he can judge. But clearly, Kelly and Daryl are always welcome at Westnet, and we will take this back to my my self-formed steering committee with Kelly Porter, and discuss whether that really involves being able to help fund those trips. And so I think everybody would probably concur that there are certain people we would love to have continue to attend as long as they want to attend, and we'd certainly be willing to help them attend. So hopefully this is not the last time Charlie comes to Westnet, but from my personal interactions with Kelly, he epitomizes what Westnet is, and we have a lot of those people, but we will miss Kelly if he doesn't continue to come. So.
Thank you very much.
All right, so we have a 15-minute break. I encourage you again to stop by, say hi to Daryl. He's another one of our special members, and take a 15-minute break, come back 3:15, and we'll get going.
One of the things that you ought to think about, though, is there ought to be an architectural standard. Because I noticed that Marl and Mr. Kelly, you want to get this for exactly the same place every time.
No, somebody took my seat today. It was shocking.
Well,
That's a big change.
He's been
Right there. That's my goal. My only goal at Westnet.
So I guess the question is, are those all on? Right. It's two-way switch.
Okay, so there's 25.
really drink it, but I didn't have a copy.
So is that one switch that was up?
Well, because there were three ways, you didn't know if you were on or off. It's just that you didn't know which one you was paying. That issue.
Okay, this one's gonna be this.
I know it's Our own issue was a lot wherever you are, just this year was good
Interesting. My wife randomly found audio. It's James Joyce of my dad.
Interesting, you know, like the things like that. That's why some of the cuts and stuff.
That was Barker's place.
Jerry Lewis.
Not that Jerry.
See, you got your, this is your path.
To me, pull it out, put the fiber in, plug it back in.
You know what?
I still told him to put it.
Do all the things you just said. So let me ask this question.
Send many, you know.
But I did. We acquired, we acquired.
Guys need. I just say, either do it or email them.
About that. Next one and the next one. That's what, that's my conceptual model. So.
But then people still complain.
But to get caught, some of what Andrew was saying, I was stopping myself at 3 or 4 minutes.
Yeah, it was cute. You changed the whole camera.
Can you possibly create a picture for my, like, tomorrow?
My eyes open in that one.
I remember in Texas where I might have
You said
So, I don't know if that's necessarily a bad thing, because, but they end up becoming constrained. Basically, it's like, there's nothing wrong with eating with the road, there's nothing wrong with your vision. These are the constraints. I have to live.
You know what?
Why was I getting those constraints? Well, because
Jeff's helping me.
That's what I, that's really good. And if you can, in some sense,
Sometimes
great.
it doesn't get a little.
Well, we're going to do wireless reading. We have some great. Right on to what you're talking about. Wireless redesign.
Oh, yeah.
But I.
How are you gonna survive without this
Show up with more than one.
Is that really hard?
And trying to.
Sorry.
For the webcam?
For the camera, but not webcam. Well, that's gonna be like twice.
We're going home tomorrow. or
Kind of like
Wednesday?
I did it late, then I went to. 8-9 flights, so I could go to work the next. I've never done it. Yeah. First time. I'm so paranoid that I couldn't save it. I'm like, I need to save this off. I've been so paranoid I'd launch another browser and play it, just to make sure it's there.
I saved it for a written stick, so you can actually go back.
You're the panel?
Yeah.
I struggle with
I feel how I'm feeling. I tried to think it. Well, I'm gonna take off. I'll be here.
How was lunch?
Good.
Maybe. I always like that, yeah.
Yeah, it was good. Right amount of time I can handle it, about an hour, 10 minutes is about it.
How old is she, 18?
No, yeah, 19. Yeah. She's like, you know.
Does she ever come to this building?
Yeah, come to Freedom Commons all the time. When she needs a Windows box. She's a Mac nut, so she comes out here and uses Windows for some of her products. After I don't want to install virtual machine and all that on her machine, I just go down there. You know, it's one of those things, you know, when you get home, the last thing you want to see is technology or having to do, you know, stuff.
Yeah.
Get it, man. Yeah, it was real good. He's got 3 kids. Boys were struggling, so no problem, man. He's just, you know, it's amazing.
Younger or older?
Just babies. But yeah, probably something to that. But I've heard that a lot of the boys, they mature later, become decent human beings about 22, 23. That's been kind of my experience. They get there, they just get there slower.
Oh, no, these are ours.
This is really good stuff. It's really good. Yeah, you guys can't believe I'm just like a sponge taking this in. I'm trying to figure out, because I've been working at Gordon, I'm trying to figure out how K-12 can help universities, you know, because you gotta have universities help K-12. You know, how do we, because there's money in the K-12 market, it's just, it's all bifurcated, screwed up. So I keep working on that.
I think every school helps their K-12.
In some capacity or another, I know. But I think because we got the kids that you're gonna have here in 14. But the thing is, there's money that universities can come out and say,
So let's see what.
spend wiser, you know, some kind of consortium thing or something. I mean, that whole Utah thing, yeah, but it's a whole different political environment. We've,
He's got two full-time people, all they do is meet. All they do is
it's a little different ballgame, man. It's pretty amazing. Yeah, we sent a bunch of people up to Utah to study the UEN. Like, hey, it's pretty slick. Here's its drawbacks, but it ain't gonna work in Arizona. Thanks for the cookie, that's what I needed.
I'm gonna start sending Richard Bridger all the job openings of doing like You guys need a backup, right? Takes one money.
So much,
Just go and tell us. You call them and say, hey, this is getting hit as a virus. And you ask, why was this getting hit? It's fixed now. Yeah, so we won't tell you. You're not fishing.
Oh, that means there might be this. Did you follow that on chat?
I think I already talked about it.
You're in the stand line there, so.
Something with somebody.
That's all right.
No, it is.
Take it away from it, huh? Yeah, the last time I was.
There was a meeting held on your staff. That we did that. I showed up. I was surprised. I could, so I was taking notes the whole time. That's how we got there, and exactly what's going on. But I sent you what I did capture.
There's a lot
Aggregating because the fundamental thing one of them is the concept so assuming that's still the case today, yeah. Right? But still,
You got your email ready to
Dave bailed on me, on us. And Brent, I don't know.
Yes.
No, I haven't replaced it. Ray's gonna talk.
Oh, Ray is?
so that's why I'm a little confused.
Yeah, those
Well, so, looks like they're
I don't see red line strikeout. Strikeout day packet.
They have it in docs, but not slides.
All right, Chad's up with the MPLS panel.
So I suggested this topic in June, and here I am.
Here you are.
I had a problem to solve. I had a conceptual model. I had a problem context. I had a vision. I came up with approaches. I did expected results, and I tried to do this. But in this architecture discussion we had earlier, I think it is a good segue because while I might have been an architect and a network architect for many years at DU, sometimes it is a circular thing of what's possible with engineering. And I might be out there with an architecture of what I want, but I am limited by I have Cisco equipment, and that's a whole other story why and what. But that really drove me to work on MPLS really hard last summer and get through it, and we're there. And I've got another PowerPoint I'm going to talk after this on large MTU that's very directly related to our MPLS experiences. I noticed yesterday there weren't a lot of slides in the group panel, so I started adding some slides last night to give us a little bit more meat to talk about today. MPLS is in a lot of vendors' minds and a lot of scientists' minds and engineers and architects' minds. It's kind of like a layer 2.5 protocol in the OSI stack. It isn't Ethernet down at layer 2, and it's not IP at layer 3, but it takes layer 3 to enable it in the first place. So we're learning a lot. What does layer 2.5 mean? And really, to pull off MPLS, you got to just kind of let your mind let go of how Ethernet and IP work, or understand how you're going to use both concepts, which in your head you always kept separate, and how you're going to make them work together. So this was a graph I found online to just kind of illustrate that, because a lot of us still do think in OSI. You know, everyone likes to say OSI is dead, but the way we troubleshoot, architect, and engineer, I think OSI is still alive myself. So what is a label? MPLS, by the way, is multi-protocol label switching or service. It's kind of a shim that gets put in the header between the layer 2 traditional NAC layer and the IP layer. And depending on what you're up to and what you're doing, it can vary in lengths. But it adds bits to the header. And I'll get to a little bit more about why that matters in this presentation and my next one. So we had a problem. We wanted to add a second border router at DU. We wanted to shore up our internet connectivity out of 2 data centers, taking 2 diverse paths back to 2 different front-range gigapop locations. We wanted to maintain a campus firewall at both locations. To get started, we had 2 firewalls clustered together in 1 rack and 1 data center. So how are we going to add a new router and split those firewalls apart and make it so we had failure scenarios that we could survive? And there's tons of failure scenarios that you can come up with in these types of problems. I was handed a deck of cards of the Cisco Catalyst SUIT 2Ts. We were lucky enough to get those as part of the presidential debate. So our whole core router switch had been upgraded to the SUIT 2Ts. So I was given that constraint from an architecture and now really an engineering point of view. I had to take what was possible with engineering to architect a solution. So that meant several meetings with my Cisco SE, reading some books, trying to understand what was and wasn't possible. It hinged on very specific versions of iOS for the SUIT 2T. But really, we had a goal. I had marching orders from my boss. We want to survive either data center going down. We want to survive a fiber cut in the city of Denver to going to either gigapop. We'd like it if either gigapop goes down, we could still stay up. We'd like to maintain security or an edge firewall. And once you added up all those constraints, this became complex on how we were going to do this. And I had to keep the network up while we did this with no new equipment. So that added more complexity. So conceptually, here's our overview. We have kind of a classic backbone design view. These are all 10 gig links with ether channels, diverse path on the campus. And what I'm showing is logically 2 border routers and 2 firewalls coming out of 2 routed cores in our network. And you'd think that'd be super simple and easy, but the way in which you cluster these firewalls, you have to make some decisions. And really, I learned in this process you could have an active-active network or you can have an active-passive network. And really, I came down to constraints where an active-passive is the way we wanted to architect it. Someday, when we need both 10 gig pipes to the gigapop simultaneously, we might go to an active-active design. But today, we're active-passive. And that really dictates a ton of config on both border routers, how the firewalls work, and how your core routers work.
What firewalls are you using?
Those are 5585s, also Cisco products, so I was given those through the debate. And so had to work with that and the complexities of how those can possibly be configured when they're in the same rack or physically diverse. Here's a real detailed diagram of really what I had to pull off is the 5585s don't have fiber ports between them for their heartbeat and state. We have to media convert heartbeat and state just to get them across the 2 data centers across the street. They only had so many 10 gig ports without having to buy more hardware. And then the ASRs, those are the border routers. They have their set of complexity, and it became really hard for me to even draw it. You know, how should I draw this? Layer 1, layer 2, layer 3. How do you draw this? It makes sense to other engineers because I'm really trying to do what Kelly said: simplify things so that I can show others so that they can fix it when I'm here or on a plane or somewhere else. And that proved to be really challenging. You bring up 2 or 3 engineers in your staff that can look at this and go, I understand what's going on here, and I know all these idiosyncratic commands per platform to see what's going on and understand it. So here's yet another way of trying to draw that. It's kind of hard to see here, but I tried to kind of get my head around the layer 3 diagram of what we were trying to do here. We have, from the gigapop into the campus. How are we going to combine BGP? We did used to use a dynamic routing protocol to and from our firewalls. I found that was bad practice, not a good practice. We want to use static routes. We had to unpeel that for this project. Then getting into MPLS, which I later learned became VPLS, virtual private label switching or private LAN switching. It's a term that Cisco uses and Juniper and others use to basically stuff traffic within MPLS tunnels to do what we need to do to extend security boundaries. And I'm showing some external VPNs here just to kind of show how those fit in the picture. So this diagram had 10 versions too, Scott, Todd. It had 15 versions. And drawing it, understanding it, going over it with my Cisco engineer, we finally got there. And so really to pull off the redundant firewalls, you have hot standby routing protocol concepts happening outside. You, in effect, have a hot standby routing protocol happening inside across 2 cores that aren't trunked. How are you going to pull that off? You need VPLS to do that. And I didn't realize till a month or 2 later, you have to pick in Cisco. Once you do MPLS, you have to choose. I'm going to do VPLS or I'm going to do things like VRFs. And I've heard lots of you talk to me about VRFs for many years and always thought, oh, someday at DU we'll do VRFs. But really, architecturally, it came down to VPLS was the better way to pull it off, what I needed to do. But I probably could have done it with a VRF concept as well. But it's turned out that there's a lot of use cases we have for this technology across our campus. When we started our backbone, we were flat, and we had VLANs everywhere, in every building, on every switch, hundreds of them, and we learned it didn't work well. When you rebooted one switch in your network, your whole network was unavailable while Spanning Tree did its thing. So we were forced into cutting up our network into routed domains to minimize that and keep a highly available backbone in place. I remember 10 years ago, Dave Wood telling me, you need to keep this centerpiece always up, always going. You can't have spanning tree bringing your core down for any reason. Just route in the middle. So that's where we ended up at DU. So with that, you're now with constraints. I want a VLAN showing up in one part of my network and another part of my network, but I have this routed problem in the middle. VPLS solves that for us at DU. So it really took this first project to get my head around the concepts, around the code, try it out in the lab, pull it off on a hot cut day in the middle of the summer and make it work with as many engineers along next to me that could help figure it out with me. And we got it. Then we had some issues. We'll talk about that in a little bit. We've since done our Aruba controllers. Those are now out of 2 cores, 2 data centers. We can survive either one of our data centers going down, and our wireless will stay up. We had a few meltdowns this fall where 1 core went down. We lost our whole wireless network. Not anymore. Now it would take 2 cores to go down. That was another one that Cindy really is like, I have this problem. We have to keep wireless up. We cannot let it go down because of 1 core router. We have since come up with our HIPAA case with health services. This VLAN 19, I have it in 4 cores tied together with bridged links. It's ugly. It's horrible. I have spanning tree problems that I've worked on, tuned on. Honestly, it belongs in a VPLS use case, and we'll get it there probably in the next month or 2. I had a point of sale, these horrible point of sale solutions. They have to be on the same wire. They don't have a concept of routing. But food services want some of these things in different buildings, and they need to be plumbed up to the back end of a POS server. That's a good use case of a layer 2 only VPLS code that we got done, and it's complete. The next one's a ticketing solution. We have to provide the plumbing for wireless for scanning tickets for events in multiple centers, and they all have to be plumbed in right behind one device. We'll get that guy done. Today he's in bridged links. Tomorrow he'll be in a VPLS config. So, and the list can keep growing and growing and growing. And you might say to yourself, well, now then you're going to end up back to a flat network. Well, you might. So you want to not do these use cases unless they are absolutely necessary. And you cannot engineer around routing like routing normally wants to work between subnets and VLANs. So big case here. So the big lesson learned is in our backbone, when we were even 1 gig, before these were all 10 gig links, we never enabled jumbo frames or jumbo packets. We always left the default value of 1500 roughly, or 1536, or 15, whatever it ends up being. We always left that alone. We never touched it. And for many, many years, some of you talked to me about you should always enable jumbo in your backbone, and I never knew why. Well, now I know why. The minute we turned on MPLS, we're turning on a label distribution protocol. We go back to the moment you turn on the MPLS command on this port, you're introducing these new bits in the header. So that makes your frame size larger than the default of traditional Ethernet. So the moment I turned those commands on, my SE didn't tell me, and it never really clicked in my head. I'm introducing larger frames than the default size, and now every frame in my network has to be examined by the CPU. And at first, in the middle of August, on a slow day, I didn't notice that. As weeks went on and we started ramping up with some real traffic on our backbone, bam, all of a sudden we're hitting major CPU issues on the core SOUP2Ts. And I have another talk about that specifically that I'm going to do after this panel. But basically, we got into trouble. We were having 100% CPU issues, and we had to deal with that. So we enabled jumbo frames, and we're out of that hot water, and it's great now. Another thing I learned, you can't do VPLS PE and VRFs at the same time. You need to pick one or the other. They're both really a tagging concept. So when you enable MPLS, it's really a label distribution protocol. You're telling your routers, you're going to carry these routers, these labels, and you're going to exchange those with these routers. And so in the beginning, to get my use case of the firewalls working, I only had enabled that on this network here across this way, which meant if this guy went away, I wouldn't have an LDP. If I don't have an LDP, I don't have VPLS. If I don't have VPLS, I don't have a firewall. If I don't have a firewall, I don't have internet access. So talk about managing complexity. You really got to get your head around what do you really need to do this, and then be resilient and redundant. So what it later meant is I had to enable the LDP here, 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 and here. And I did that and I broke a bunch of other things. FTP stuff stopped working. Weird results occurred, which forced me to back off, examine long TAC cases, packet capture, figure it all out. We got it figured out. Now we're enabled in our whole mesh for LDP for redundancy. We still are having some ongoing issues. I can't do trace routes from router to router from the loopbacks. I don't know why, and Cisco's stumped. So we'll figure it out. I know we will, but that's still ongoing right now. But we're passing LDP, we're doing MPLS, we're doing VPLS. We have a redundant internet, we have redundant wireless. So it's like you got to
and then stepping up to run L3 VPNs it's not just extending the same protocols to do the next thing, right? It's almost like a completely set of protocol suites that need to be run, and depending upon your vendor of choice, it's not doable, right? You know, you have to choose one or the other, or you have to make very clear architecture decisions when you set it up that you've got to have certain things set up in a certain way, or else it's going to be a problem.
Well, and also the vendor of choice, the cost. I mean, Cisco charges you 10 grand for MPLS. Obviously, they charge us. I don't know if
we had the enterprise version on our equipment already, so there was no cost barrier there. Yeah, but that's what we paid. Yeah.
So it's an extra licensing cost for MPLS?
Yes. Oh yeah, it's enterprise. You have to be running enterprise.
Okay.
Yeah, and so that's one reason why VERFs are important to us, because, you know, we extend out to clinics and everything else, and so it's, you know, we can't always justify that extra 10 grand to be hanging on every single switch we go.
And that 10 grand is applicable for VERF Lite as well as regular MPLS VERFs, or not?
I believe it is. I'd have to look at the licensing, but I think it is.
What did you end up with, Brian? Did you just go with VERF Lite for a bit?
Yeah.
Well, did you pay extra for?
No.
I don't think it's a license on the
Yeah, I
Cisco
don't think
side.
VERF
It's
Lite's
it's limited to 4, right? On Lite, you're limited to 4. Right.
I just know that whatever we're doing, they send me the bill. Every time we go to anytime we do the
You have to bump that and then the license.
So, you're right. I'm glad Kelly's seen the same thing.
Yeah, the last time we needed to buy a license was for the hospital. They put equipment down in St. George, Utah, in a data center down there, so we needed to be able to span things down to that data center, so we had to buy another license.
Yeah.
So,
Yeah, we're doing VRF Lite without a PLS, so
okay.
No additional license for that.
the other thing, and I'm not as familiar with LACP, but with the VRFs, the thing that's really nice too is all of the security domains stay or are propagated throughout all of the distribution nodes. So that makes it really nice too. We still though have one-offs where we have to get that traffic routed to another place off of that VRF, and we use firewalls to do that. So,
A lot of ifs, ands, and buts.
yes. Yes. If you can keep things to one-offs to a bare minimum, you're going to be way better off. But it's easier said than done.
It is. Yeah.
So that's kind of.
Bring it beyond. Anyone want to talk?
Sounds very similar to what we're doing. We run MPLS before, we run VRF, just trying to very similar.
Okay.
So I'm talking from a different perspective. I do run the Noel Boulder campus, but we aren't running MPLS on our campus, but we do run it on our nationwide inway backbone. And so it's running more the typical carrier MPLS network with VRFs. It provides a separation for the various node programs that might have different locations of the same program, so we need to connect those different entities together across our backbone and have them communicate with each other, but not to anyone else. So those are layer 3 VRFs. We also do support layer 2 pseudowires, where we're basically giving an office Ethernet connection on one end, Ethernet connection on the other end. It's a pseudowire, so they can connect up those two LANs. It depends on whatever the customer needs are. We have a shared backbone. It's running on top of 10 gig waves, and so we're able to overlay these layer 3 VRFs and layer 2 pseudowires on top of that backbone, and they share that common backbone bandwidth. So here's a diagram of our MPLS network. Core locations are Seattle, Denver, Chicago, Atlanta, and DC. And then we have a lot of aggregation sites and participant sites that are indicated on here. And we pushed out MPLS out to all of the aggregation sites, so it allows us to extend those VRFs to those various locations. So there's a lot of different NOAA entities at these various spots. Chicago doesn't actually have anything NOAA, but it's a good good core location, through a junction point and that kind of thing. Here's an example of one of our VRFs. It's for our R&D high performance computing system. So there's supercomputing either being done or supercomputing resources at one of these 5 locations: Princeton, DC, Fairmont, Oak Ridge, or in Boulder. And so this RDHPCS VRF connected up those 5 locations so that it could, again, connect up the researchers that are at some of those locations to the resources which are at some of those other locations. A lot of communications any-to-any. That's one of our layer 3 VRFs that we have. But any other NOAA entity isn't connected up to that VRF, so they can't talk to those resources through this VRF.
That's a full mesh configured on each router to the other 4, right?
Essentially. So the edge talks BGP into that VRF, and then that VRF is extended to all those 5 locations. So it's not necessarily a pseudo wire for each one of those connections, but it's a full mesh in the sense that they can all talk to each other over that VRF. Another one overlaid on top of that same backbone. This is class, so this is our distribution of satellite information, which comes in off a satellite downlink, comes into our DC area, and gets distributed out to our 2 data centers in Boulder and Asheville, and from there gets served out to the public. So this is just that back-end distribution of data from basically the head end to the 2 distribution points. So that's another VRF that's running on top of the MPLS backbone, sharing the same backbone, but since those are 2 different VRFs, there's no communication between those 2.
And there is no communication even at layer 3 through one of these buses?
For these specific applications, they are not. So if they did need to, there could be some exit points that these programs have. Say in Boulder, they have internet access points for the specific data. So other NOAA entities would connect into, get to it essentially over the internet.
But basically, they look like private viewers.
Exactly. So it's essentially like if CenturyLink gave you dedicated connection between these locations, and you build your network on top of that.
And so I've learned that that's called a drain, what David asked about. Where does this drain? Where does it have a default route out or in or a firewall? And it could have more than one drain. But sometimes you create layer 3 VRFs or MPLS, VPLSPs without a drain. Sometimes they have a drain.
Right. These ones in particular do not. So, like I said, what was I trying to say here? On our enterprise backbone, so our previous backbones were kind of purpose-built to fulfill a particular project or mission. So a lot of programs went out and bought circuits from CenturyLink and built their network backbones to support whatever mission they had. So N-Wave is kind of the new network that is kind of supplanting that carrier network and providing MPLS transport for these various programs. Another thing that has brought up a need for more of this MPLS and DRS is our TIC effort, which I'll be presenting later on this afternoon. Basically, that's a way for NOAA to get to a specific access point between NOAA and the internet. And we're actually providing route leaking to provide no inter-network communications, and I'll go into an example of that. So here's an example of a TIC VRF. So one of the exit points in terms of an internet access point for NOAA, one's in Denver, one's in DC, one's in Seattle, and one's in Dallas, which isn't shown in this diagram. So here's an example of 2 different VRFs for the 2 different high-cap access points, one in the Denver area and one in DC. So let's say our Miami office and our Northern Oklahoma office are using the Denver TIC access point, and our offices in Princeton and Fairmont are using the DC TIC access point. So in order for, say, Princeton to talk to Norman in this scenario, if there's no route linking happening, they'd have to go out to McLean. McLean has a connection to the internet. They do over internet 2, Denver, and then Denver to talk to Miami would again come into the internet and then could travel over this MPLS path to Miami. So what we did is we implemented route linking between these two different VRFs for the specific NOAA prefixes, so that traffic doesn't have to go to the internet for NOAA to talk to NOAA. And even better, so say Fairmont needs to talk to, let's say Boulder. They wouldn't have to go to DC, then back out to Chicago, and go over to Denver to get to Boulder. You could take the direct path from Fairmont to Chicago to Denver to Boulder. So that's kind of an example that Marla was alluding to, where a lot of the NOAA to NOAA traffic is now being pushed off of our Internet 2 pipes, which was traditionally what our research arm was using as their backbone. So we're seeing a lot less utilization of the Internet 2 backbone for that in terms of a layer 3 routed resource.
Alex, do you have a sense of how much traffic got pulled off? I mean, have you measured that? I'm just curious.
It's a little bit hard to gauge because kind of what is the impetus of building this MPLS network is the creation of these new supercomputing sites, which were not co-located with researchers. So we built up supercomputing sites in Oak Ridge and Fairmont, which is not where the researchers are, so there's a lot of data movement between those sites. And those are two node locations, so how much traffic was actually going between, say, Boulder and Princeton? There probably wasn't a whole lot. So, in short, I don't really have a good answer.
Just curious, thank you.
Because there are too many things happening at the same time.
It changes.
Some lessons learned. We built our initial, or it's still, our MPLS network is built on top of LDP. It was easy to deploy, but it doesn't give us the flexibility of doing any traffic engineering. So we can't say, let's direct this traffic over this underutilized link, because LDP follows basically the IGP shortest path within the MPLS network. So we're going to go through and migrate over to RSVP. That will allow us to enable that MPLS traffic engineering. Other lessons learned, pushing MPLS out to as far as we can out to the edge was advantageous, because then we could burst out to the edge and again gain some optimal routing. As was noted, monitoring those layer 2 pseudo-Rs is difficult. So even though we've offered that service, it's been somewhat of a problem because we have no way to monitor it. And with our layer 3 VRFs, we have IP addresses, we have BGP sessions we can monitor, and all that kind of stuff. Layer 2 pseudo-wires, we can't even get good NetCell data that'll show what's in those layer 2 pseudo-wires. So it's a challenge. So we're actually trying to discourage the use of them where we can. And like Chad noticed, there are MTU issues. We have some networks, Metro Ethernet connections in Hawaii, where the MTU was what they call jumbo frame, right? But it wasn't 9K jumbo frame. It was just slightly above 1,500 bytes. And so when we added these headers in there,
baby jumbo, they call that.
Yeah, it broke. So just like Chad said, it broke, and so you just got to be aware of it. And I think that's all I have. So.
The MTU size is a big deal.
Yeah.
People, they think they have the packets matching on the right size at one layer, and then they forget it at the lower layer, and then you have all sorts of mystery problems that seem to be just intermittent.
Yeah, the problem is the carrier didn't know what they were doing either. And they had Q and Q on there, so they had even more stacking of labels, and they didn't really understand what was going on either.
Yeah, we have a significant issue for that.
Could you say again what you said about the third bullet up there?
Pushing out MPLS to the aggregation sites, that one?
Yeah.
So initially we just had MPLS in our core, our backbone, those 5 core locations. And there are a couple things that proved to be problems with. One, we couldn't push the VRFs out to the edge as far as possible, so we couldn't allow a certain office to connect up to, say, a ticket VRF and a program VRF, without having two separate physical or logical connections back to our backbone. And so when we pushed it out to the edge, it allowed them to do that, and also gave us better availability because we could rely on the MPLS resiliency out to that aggregation site. In particular, for some of these layer 2 pseudo wires, when we built it out to, say, the core and then extended that pseudo wire out to, let's say, the pseudo wire terminated in Denver and we want to extend it all the way to Boulder, we didn't have that pseudo wire traverse over both sides of isotope. Over one path, when that path gets severed, then we obviously experience an outage. But when we pushed MPLS down to Boulder, then you can take advantage of the resiliency of MPLS across that ring.
All right. Well, Alex and I swapped on the agenda because I thought my talk would be real relevant to coming out of this talk, and I have to leave a little bit early, so we agreed to swap. You want to just move right into that? Do we feel we need a break, or just go right into it?
Go for it.
Okay, let's keep going.
So while you're getting set up there, I'm curious, with everybody who's running MPLS layer 2 and doing pseudo-wire type technology, is anybody looking at the provider backbone technology and thinking about extending kind of the layer 2 circuit on the network in a protected way, but sort of minimizing in a great way the routed infrastructure within their networks? Consolidating routers and then pushing out the L2 to the edge in a reliable way that gives people access in the same reliability, but again, a different technology. Has anybody looked at that at all?
Well, we kind of do that on our backbone. Noah's example is a true example of a WAN example, and it's very common in any national or international carrier to see that design. What's new in the last few years is doing that design on a campus LAN, leveraging routers on a campus LAN. And at DU, we don't have the luxury like UEN and Todd does, where you're pushing out routes and route decisions even to a distribution layer at a building. We can't afford it. We've effectively collapsed that routing in a few key places on campus and tried to do dual soups, dual power supplies, do our best job to do that routing there and not incur the licensing expense, the more expensive switches, but yes, at the cost of resiliency. If we lose that single core, we're not routing and we don't have networks out of that core that might affect 20 buildings. So it is a cost-risk analysis that has to happen there on a LAN.
The thing that I would offer is that with the newer technology, especially in campus situations where you've got a lot of fiber infrastructure, then you can use that technology, which has better monitoring and maintaining overhead capability, to validate whether your L2 connections or your pseudo wires are up and running and what the error statistics are there. They have the failover redundancy, so it gives you kind of like a sonic failover feel on an Ethernet type technology. And unlike my experience with MPLS, where it's like a lot of hand configuring stuff and making things stitched together, it's more the operating systems for these are more polished, where you can just it's more like an OESS feel where you can nail up connections, put them into it, and then it'll go out and automatically make those connections for you. So I was just wondering if anybody had actually looked or had experience with that kind of technology. You're
describing software-defined networking, right?
It's software-defined networking, I guess, if you want to call it that, right?
I know.
Flag on that, but
kind of joking.
Right, but I guess the thing is that it would be software-defined networking in the same vein as if you had Cisco Works being able to go out and you ask it to make the architecture configuration that you're looking for, and it just automatically does that, right? So is that really software defined network?
Well, so we did that in a perf sonar training up in Boulder, where we kind of did what you described, using a soft switch, a soft firewall, soft load balancer, all in the Amazon cloud. Did it all conceptually, hit go, and orchestrated it out, and did it. So to me, that's where it kind of is software-defined networking. But yeah, I don't know.
One more thing, how many people have the luxury of connecting down to the building to two, like if you're at layer 2 or layer 3, do you have connections to 2 different sites per building, or you just going in once? Does that make sense?
Meaning back to 2 different cores? Yeah.
We're going back to 2 different routers.
2 different routers.
Two
different sites?
2 cores that are next to each other in the same site.
Same site, okay, but not different, you're not going to 2 different physical,
No.
geographic, okay.
We want to get there, I think we
Yeah.
can now. It's just a matter of physically.
Okay.
Yeah, we don't have it, but when we do our next fiber, whatever, however we're gonna fund the next round of fiber, we wanna make sure to do.
But I'll caution, it turns into a better type of distribution switch. You've got to buy that routing license. You've got to now only have VLANs that are only in that building, or extend VPLS or MPLS or VRFs of some sort to bridge those to other parts of your campus. So you're just pushing that complexity out, but adding redundancy, adding cost, but adding resiliency. You know, you can't have it all. So I've already really covered all the bullets here on the last presentation. What drove us to have to worry about jumbo frames and packets? Well, it was the MPLS or VPLS PE. By the way, PE stands for Provider Edge. It's a play to do Metro Ethernet typically in a metro area. Usually a carrier would do this on a national level or a regional level or a citywide level, but we're really doing it on a campus. So we wanted to split our firewalls, go with 2 border routers. We enabled MPLS. It caused a 40-byte header to be added, causing fragmentation. DF bit set to 1 caused high CPUs for every packet to be inspected. And I've seen examples where poorly written applications, either by design or fault, are setting this bit to 1. Same diagram I've already shown. Same diagram I've already shown. How do you see fragmentation in iOS? Just a global layer 3 command, show IP traffic. You're going to see this. In our case, this number was this long. I mean, it was off the charts of fragmentation. And trying to even hunt down these are difficult. This was a quick view of, I think the box has been up a month. So those are hard to find. What I've learned, it is all, so first let's talk about frames, layer 2 frames. You're going to make the frames larger so that you can talk about a layer 3 packet being larger. You got to start at layer 2. It depends on your platform, and they love to tell you at Cisco and TAC, it's the platform and the platform team and the platform this, and it really comes down to ASICs and hardware design. So on a 6000, it depends on your soup and your line cards. And the good thing about the big switches is you can do ether channels or individual ports, not the whole card, things like that. In a 4000 line, it's the same thing. It's a combination of the supervisors and the line cards. We have soups that support jumbo. We have line cards that don't. We're out of luck. We can't enable it on a 4500. All the rest of the models on the way down this list are models we have at DU. It's a global command. You'll tell the switch, hey, I want to be able to do jumbo frames. You hit go, requires a reboot. It's a programming ASIC difference. You can't have it either way on those. It's all or nothing. So we've experimented. We've solved our backbone problem, and that's fixed. But now we're really looking at, okay, do we want to extend jumbo out to every building and every switch? And we think yes. And so we're trying it, and we're experimenting, and we're walking cautiously. I've heard a lot of you in the past tell me how it can be a nightmare.
Just go to Nexus and solve.
Say again?
Just go to Nexus switches all the way out to your building.
So we kind of look at it as arms of a tree, limbs of a tree. We've started at the core. We've then going to implement all the SVIs. Now we're going to do one building at a time, and because these reboots occur, we have to do them in the middle of the night or plan these things out and be ready to deal with it. Now, once you're past frames, you're going to start talking about packets. Okay, we're going to route packets that are larger. And in a Catalyst, we use switch virtual interfaces. This is the layer 3 construct in iOS to route your VLANs. And DU, after a long talk and a lot of reading, we've kind of standardized that we're going to set the SDI to 9216. And I may be telling you something different in 6 months, but this is what we think right now. So at DU, we have backbone and some point-to-point routed, which are a combination of SDIs and ether channels, layer 2 ether channels, and point-to-point links. In the case of our diamond here, all these diamonds, yeah, they're physical ports. The physical ports are comprised of a layer 2 ether channel. The layer 2 ether channel and ports are a member of a VLAN. The VLAN is really an SDI, so your head starts to really hurt, like, well, where and how are we making sure that the frames are going to do it and the SDIs are all packets? And there's some ifs, ands, or buts in iOS on what you can and can't do. We're learning. What we've learned the hard way is that even in a 6000 chassis, it depends on your line card, and it depends on the line card if it has the CFC or the DFC card on it. If it's got the CFC card on it, we found the settings for the whole card. If you have a DFC, you can set things per port, so that adds flexibility. That impacts us in our data center because we have some cards that are still CFC in our data centers. So we think, I kind of want to switch gears just to talk about the WAN and the gigapop. What we've done with our border router is we've configured our 10 gig ports leaving the campus at 9216. We use CenturyLink ROADM or wave gear to get down to the gigapop. That ROADM gear will carry and allow that size. It really doesn't care. It's just a lambda. But then working with the FRGP engineers, we have sub-interfaces on our routers, and we've configured the R&E for 9000. And that seems to be pretty prevalent on the Internet 2 backbone and within gigapops, is everybody's kind of settled down on 9000. So our perf sonar box that we had hanging off our border router, when I went to the perf sonar training, we could not figure out these really wonky graphs, and it looked like a cone. And once the Westnet guy took one look at it, he goes, "You got an MTU problem," right away. And went in, looked at it, and lo and behold, I had done mine end, the Gigapop forgot to do their end. They fixed that. The next day, that graph looked beautiful. So you really can't have a mismatch on either end, and perf sonar is a great tool to see that in your WAN. That was a really good learning experience. I don't show this on my diagram, but really we have in our primary path to the gigapop, primary border router, primary firewall, we've got this thing called a FireEye sitting in the middle of it. That's our anti-malware box, 10 gigabit in, 10 gigabit out. Every packet gets examined, and guess what they don't support? Jumbo. So I'm stuck. I can't even do jumbo from the gigapop into my LAN right now. But I'm there. I'm so close, and I have an engineering request in, and I have an email into them, and they're supposed to have support real soon. But it goes to show you, if you don't have all the devices along the chain from the WAN to the LAN, you're not going to be doing jumbo. And I don't really have a huge research community like a lot of you, so no one's really complaining to me, going, "Why am I getting this slower throughput?" At least that I'm aware of. But we think it's going to be soon that's going to be allowed. I just show you some useful commands on the 2T. We're seeing now when we do the show VLAN MTU, like we'll go ahead and get all the SDIs done, we'll do the show VLAN MTU, and we get this funny column saying too big. And then it points to a specific port and card where that we haven't enabled it yet on that port or card, so it's kind of a funky output and queue. But you do need to think about MTU mismatches. The lower commands really, this is a typical command to kick a little switch into gear that you're going to do jumbo. You're going to set it and then hit go. And it's all about the platform. Some of the platforms will support a larger value here. In our data center, all we've done at this point is extended it to the data center switches. We've not taken the next step to go towards the servers, the UCS chassis, the little switches in between the Flex WAN card or Flex cards to the HP chassis. We haven't done that next step. I've heard from a lot of people, and I've read, you need to tread lightly here, work with your system administrators, make sure they're ready to do that same setting on their side. You do it together. Sometimes they have to reboot, sometimes you do, but we want to get there. We think this is worthy to do it. So we haven't gotten there yet. They talked to me in 6 months. We found a really good research paper from Purdue where a bunch of researchers went after this, tackled it, and at the conclusion of their paper, which is hyperlinked, they say in the end it's worth it if you do it. We have backup servers that are maxed out and taxed out, but we're doing 1 gig ether channels to those, so even enabling the jumbo, what we're already seeing are those links are saturated to 900 megabit already. So the jumbo's not going to buy you too much. We think those need to move to 10 gig links, and then jumbo would really help you out there, and maybe we could shorten our backup windows. That's a goal of our backup administrator. In wireless, we've learned that Aruba, our wireless controller, only supports it on a 802.11ac WAPs, and there's some limitations what can and cannot be supported in the version of AOS that we're on. We want to try it out and test it, but most of our WAPs are 802.11, so it's not even a discussion. So we haven't turned it on, and we've purposely not enabled those links or SVIs today. In our testing, this is from a Windows box. This is how you could force a Windows box to do a large size. This is right from my desktop going through a switch that's not enabled. So this is what you'll see on a test. You're saying don't fragment this packet, but the switch in between has to, and you'll see this output back on a Windows computer. Here's a real basic command I found online on a Cisco SVI on a layer 3, how you configure it and how you would force a ping of the right size to try to see if it's working, if jumbo's working in a campus LAN. This is part of the problem I'm having with MPLS right now. I'm not able to run a command like this because of my other issues. Gave you a lot of resources. There's tons of reading on this topic in the gaming industry, or gamers, all the gamers and the jockeys who want to have great performance in their home LAN with between their NAS and their desktops. Lots of talk about jumbo and where's the sweet spot in the home environment. There's a couple articles there. And I found this one graphic. Yeah, the other girl is laughing and call me jumbo frame. I don't even get it. Well, yeah. Anyway, so I'm still learning. You know, I'm kind of half scared to keep going down the jumbo road, but I know I had to do it on the backbone. That's done. If the whole campus can benefit from it, then great. And we've whiteboarded many scenarios of what would happen if we enabled it in this part of our network, but not over here. And we believe TCP can deal with it. It'll send a TCP MSS message back to a server. Hey, I'm not even capable of doing this jumbo thing, so we're not even going to try. So we think from a TCP perspective, if we have parts of our campus enabled and not others, we're going to be okay. But there's not a lot out there on this, I'll tell you. So this is one of the reasons for me presenting today is I wanted to walk away with some jumbo MTU friends today and talk to you about your experiences with it and what's working, what's not working in your campuses.
So did you see any performance issue when you had that MTU mismatch at the front range gigapop? Did you see anything weird at all?
Well, we've got our 10 gig pipes. On a busy day at DU, we're just hitting 2 gig, so we're really not, you know, we're in the 1 to 2 gig on a typical day, and again, we're running active standby, so that's only even on 1 link. So I really can't answer you other than poorly drawn perf sonar. Yeah, perf sonar was suffering, but we're doing scheduled tests, you know, to NOAA and the gigapop. Those were suffering as a result of that mismatch. But I never got a phone call.
Yeah, but that's one of those pesky things that's lurking in the network that can cause problems. And if you're not monitoring or running perf sonar, we have had users call and it takes a while to figure out, oh, everything's not synced up. So you want to be running.
And we don't have a perf sonar inside the firewall in the data center yet. That's on our roadmap this year to try to do that. But really, if I've got this fire eye in the middle, it can't do it. I'm going to have performance problems just getting through that thing. They're telling me it would pass it, but you'd lose the inspection ability. Well, that's why you bought this very expensive appliance, is for inspection. You don't want to break that. So
your users would never figure out if they sent a jumbo it wouldn't get inspected. Nah.
Yeah. Right? Malware? Yeah.
So do you have any applications that you've identified that set the DF bit and you can't?
That has been very difficult. No, I know I have traffic. Here's where I'm seeing it. It's tons of traffic from map drives, from computers all around the campus to our NAS headends, our Hitachi NAS headends. And I haven't gotten a straight answer out of Hitachi yet, but all this is SMB port 445 traffic. It's simple as mapping a drive to a share on our network, and that, we service hundreds of shares. And so I'm on the phone with Cisco, and they're like, go stop that. Go turn that off. I said, really? You want me to go turn off file sharing for my users? I can't do that. Well, it's these large, these packets with this DF-bit1 turned on that's causing this. Because we would do these long troubleshoots where we realized it was really the MPLS traffic that was firewall, which is all of our in and out of the WAN, causing some of it. That was easier to identify. Then all this other, high volume, bursty traffic that they, would cause these spikes. We wrote these really elaborate EEM scripts to grab it when it happened, then go analyze the whole thing and come back and look at these IP pairs. You'd go hunt all that down. They're mapping a drive and moving hundreds of megabit. And when you really go hunt one of those people down, we've told them to do that. We've said, you need to start using our central storage. So what am I going to go tell them to not do that? That's just where there was a big disconnect in what a Cisco TAC engineer, escalation engineer is saying to you, and you going, well, wait a minute, this is one of my core applications on my network. I can't just turn it off. The right answer was enabling jumbo. That was my takeaway here for you. I probably had that go. I know I did. I had that going on before MPLS. I had these bursts of big file transfer traffic that was causing fragmentation at times, or the DF bit was set to 1. And so what I've learned is when that happens, yeah, CPU's got to look at it. So, you get these spikes in the CPU, and you go, what are these? Well, they're just normal traffic on your network. And an engineer once told me, oh, Chad, you need to run your network with 0 counters and error-free. But we can never get there. We know it. We admit it. It's just not the way it's ever going to work on a network. You're always going to have some kind of errors and problems, and they're going to be very elusive to find at times.
More questions for Chad?
Another group question. Anybody else that's using Globus, have you ever seen a benefit having jumbos all the way out to I2, other WAN sites,
We use Globus.
versus not having jumbo enabled?
Globus is the software package on a computer for large file sharing. Right, yeah.
I would think anytime you're doing any file transfers over Globus, you should be doing a jumbo thing.
Every time we've had bad luck with jumbo so far, mostly in the storage room.
I would have to verify that. I would assume we're running jumbo, but I would have to verify we're running jumbo.
What's the bad luck?
It depends on what kind of information you're transferring. Sometimes if the packet is generating all the way up to 9,000, it's like it holds on to it longer before it'll send it. It's waiting for more content. We saw that between our NFS shares. Yeah.
Oh, yeah, that's true. There are some applications that want to fill up the packet before they send it.
And it was, well, I think it was a backup application rather than primary problem, which surprised me. It should. Just curious.
Very nice.
All right, I'm going to jump to Alex. Alex and Chad swapped without permission, but.
The duck hasn't been wrapped.
I will remember that. You're both going to have extra copies. So Alex is us. Dave, are we set for dinner?
Dinner tonight?
Yes.
There's a crowd that we're at 6:30. They're expecting a big crowd.
Yes, so 25 of you signed up. Makayo map requested. It's over by the train tracks on the other side of the hill. It'll probably take him about half hour to walk.
So are we going to PC call at 4:30 or not?
Yeah, PCI compliance.
What street's it on, Mark?
It's on Ash. Is that the one on Ash?
I thought you just
Over
said
by the train.
Yeah. Ash.
Well, yeah, so what happened with their schedule?
So
We
PCI.
are,
Oh, you're good.
we are kind of running late.
No, because you don't have your 5 o'clock now.
Your 5 o'clock stuff.
Your 5 o'clock then.
I know, but where did Alex happen with?
Alex went to
I
5.
just switched with chat. So PCI compliance is now.
PCI compliance
So
is now,
Steve
and
will
Alex is
ask.
We're running late. What happened? You were supposed to be right after. Oh, you're saying you can switch.
Yeah.
So you good? I can email the whole list of what Ohio is.
So, Dave, is this your session? Is this your session?
Should they back and panel?
It's the You just want me to talk? Okay.
I defer the floor to Mike there.
I like that Dave just cussed himself out.
So this may be the shortest session ever, which is fine.
We do have a remote presenter who's going to participate.
Okay, let's let the remote presenter go then. Who's on remote?
Steve Lovas from Colorado State.
Hey, Steve, go for it, and then I'll go after.
Okay. Yeah, it was. Can you hear me? Okay, volume's all right, and.
That's good.
Yeah. Okay. Yeah, it was a little unclear what was meant by panel discussion and who would be on that, so I put together some just a few slides to sort of give an overview of the issues that we're dealing with the new version of PCI that has come live this year. We're just finishing inking up our annual report for the previous calendar year under the old rules, and the new version 3 takes effect now. A few of the issues turn official and become reportable as of July of this year, but most of them are already in force. And we're finding that changes some of the dynamics of how we do PCI compliance, and some of the things we have to pay attention to, and a few issues of scoping that have caused us some concern. So I'll just run through these and maybe ask for some feedback about how other people are dealing with a few of these issues as well. If I can properly share my presentation. I did practice this. It did work. Just a matter of getting the appropriate.
Yeah, share your whole desktop.
Yep, looking for that button. Sorry. Something about full screen presentation mode and Google Hangouts makes the control buttons mysteriously vanish. So let's try this again.
Move your cursor.
Entire screen, share. Got to do it in the right order, I guess. All right, can you see my slides? I hope.
Looks good.
Okay, so basically there are just a handful of categories of issues that are different with the new version 3 of the PCI data security standard. One of the big ones is scoping. There are some enhancements around documenting and getting acknowledgement for third-party responsibilities. There are some enhancements around physical protection of point of sale. And then there are some issues that revolve around the evolution of standards and technology, both in the rules and more generally surrounding credit card technologies that I'll just touch on. So scoping is a big one that's gotten a lot of attention, a lot of conversation, and I know that Some of the Colorado schools have been talking about some of these issues, particularly this third one. But so briefly, there's a little elevated requirement for using penetration testing to confirm that our strategy for segmentation is working. If we're claiming to segment off only a small portion of our network for credit cards, we need to up our game to actually prove that it's set up properly. There's insistence that some other services on the network that might have been previously ignored are actually in scope, things like DNS and authentication services. The big one, though, is this notion that lots of merchants, particularly in higher ed perhaps, have figured that outsourcing the payment authorization via a web redirect, so hit the payment button, you get pushed off to a third party, and that third party communicates with the user to authorize the payment, and that means that the web server doesn't have to be secured to the standards of PCI, it doesn't have to be considered to be in scope. Well, that's not so much the case anymore. There's been some discussion around precisely the PCI Council's intention and meaning, and whether shades of different interpretation can still get us out of this. But realistically, the intent seems to me to have been to bring those web servers back in scope. So we're going through some discussions about relocating some of those servers into a dedicated area of our data center behind a PCI firewall, whether entire applications have to be moved or just certain portions of the application, certain parts of the logic. So we're still in transition for that requirement. And there's more stress about awareness training, in a sense bringing people in as part of the scope of coverage. We're also trying to take some transactions out of our scope. We moved across the threshold from a layer 3 to a layer 2, or level 3 to a level 2 merchant based on number of transactions, and that ups the requirement in terms of certified assessors doing the report. And so one of the things that we've been requested to do by certain merchants is to add PayPal to the number of possible credit card authorization schemes. And what that does, at least under our interpretation, is mean that we're not actually dealing with a credit card, because we're pushing the entire payment off to a third party that may or may not use a credit card at all. So that's a different kind of thing, and we're waiting to see whether that it becomes popular enough that it takes us back down under the threshold of layer 2 merchant. So I mentioned the third-party responsibilities. We need to step up our documentation and get some acknowledgement in contractual language about specific responsibilities under PCI, not just that they'll be nice and follow all the rules, but very specifically what the vendor's responsibility is. And that's something we haven't done before. We've insisted on general language about credit card protection, but we're going to have to be specifying a little more in depth. The two-factor authentication requirement for contractors has been hinted at for a long time and is strengthened at this point under version 3, as well as unique vendor credentials, where a support vendor won't have the same login for all of their contracts, but will have a unique credential just for us, so that if that credential gets compromised, others of their customers won't also. And all this gives us a chance to really think about what our scope is. Not only the servers moving around, but the who does what, and does that still make sense? Is this an opportunity to redistribute some of our risk by redistributing some of the responsibilities? The physical protection of point-of-sale devices, there's been some discussion around whether that really requires physical enclosures around all of these terminals. That's certainly one possibility, but other things like regular site visits, user training, telling people how to inspect their point of sale terminal daily to make sure it hasn't been tampered with, adding some technology like tamper evident seals or serialized tape around the thing. And then I mentioned the evolving standards and modern tech. One of the most surprising and perhaps interesting is that SNMP v2 was added to the list of examples of insecure protocols that shouldn't be allowed in a credit card environment. I've been looking for a good excuse to push the notion of SNMP v3 as a standard, and of course there are lots of good things that we ought to be doing, and projects rise to the top as they become a little more crucial. So here's a hammer to at least begin that process. One of the options for merchants, particularly that wander around or that use remote credit card authorization, maybe at an auction that they're holding out at a hotel or an event out in the plaza or out in the field, is a cell-enabled terminal. It's kind of clunky, much bigger than a cell phone, more like just a handheld version of your desktop credit card swipe terminal, but it has a cell plan, and it has been seen as an option to use that gets away from any intense need for security concern because it's not crossing our data network. Well, the CDMA has been added as an example of an open public network, and so at the very least we need to make sure that these things are properly doing end-to-end encryption so that we'll be safe there. Along the way, we're looking at other kinds of wireless and cellular use. There's been a lot of push to use something like the Square devices on iPhones or something like that, and so we're exploring offerings that are supported by the bank and use approved end-to-end encryption hardware, and looking at what we might roll out and how our policy might change to make that a possibility under the rules. And then finally, coming this year, or already here in at least a partial version, chip-based authentication, whether or not the industry in the US decides to implement the PIN along with the chip. Either way, we're going to have to replace some aging terminals. That'll also give us the opportunity to support near-field communication for things like Apple Pay and other competitors. So we're reevaluating lots of our policies as these new technologies and opportunities come into play. So that's really since I didn't know how many people would be participating in a panel and how much time we'd have and whether you'd be on time, that's what I prepared for a written piece. Are there comments or questions or discussion that anybody else in the room wants to bring up on any of those? I hear crickets.
Yeah. Well, it's interesting to see what you had written. This is Mike Exton with the University of Utah. Since this came to me a couple of, as I was talking at dinner with Dave Packer or whatever, I didn't bring any slides, but what you have described is very similar to the things we're looking at. The only difference is we're not trying to get down to level 2. We're just trying to survive the fact that we've been forced to go to level 3. Has anybody else had that fun, being forced to go to being a level 3 merchant?
Well, we anticipate that in the next round of the 2015 round of auditing activity is that they, in fact, I think they have told us that they will judge us based on level 3 standard.
So for those of you that haven't been told this, count yourselves blessed, because basically it becomes, I mean, you have to pen test. You do not, I mean, every year you have to go through a full pen test. And you have to have not just documentation, but you have to have everything verified. I mean, it's around a $500,000 investment. You have to pay like a Fishnet or whatever your favorite applied trust. You pick the security services firm that's a certified, I forget the term for them, but you have to pay for that, and you have to do it every year. And so in our case, as the University of Utah, the reason we got thrown into this mess is because basically they looked at all of our purchases across all of our different merchants on campus and said, your total number of transactions now exceeds the amount that qualifies as a level 3. And historically for us, and I'm sure the way most of you are probably being dealt with right now, each of your, your ticketing booth, your lunchroom, your whatever, they're all in individual merchant accounts with their own relationship with the bank and doing their own little thing. And so in a sense, you're flying under the radar because each merchant account is being treated as a small entity. Well, if your banks and the people you're working with get smart to that and recognize that really all these little merchant accounts are part of a bigger organization, then all of a sudden the game's up. And they add it all together and they say you have to be a Neiman Marcus, you have to be a Walmart, you have to be, and so you have to literally start matching the standards of a really big organization. The bad problem about PCI for a university in this case, and to be honest, we're the only ones we've found that have had to go through this pain. We have, yeah.
Well, go ahead.
And so if you found other organizations, we used Fishnet as our auditor. He came out after finishing a year-long project with us with 800 pages of documentation for his audit. He has experienced audits for 20 years in PCI, and he basically said he would rather do Walmart 10 times a year than come back to us ever again. And it's not that we were terrible, it's that he basically gave it as an analogy as being forced to go into a city and tell the city that the entire city has to match and follow the same standards and procedures. And that's a really good analogy. He had to document and work with us to force 500 acres, 50,000 people, hundreds of merchants who had never talked to each other before to start working to a common set of security standards. And Jeff, who's now at BYU Idaho, he had all the...
For that reason.
He had all the fun of building our multi-factor authentication solution because it goes through your entire staff. I mean, literally every switch has to have multi-factor authentication. Everything that has a PCI packet going through it now has to meet the standards. And so just imagine your entire infrastructure that's getting touched by these PCI packets all of a sudden having to be vetted by an external auditor. And so it was very painful. And in fact, even though version 2 was all that was in effect, as Steve was mentioning, the difference between version 2 and version 3, even though version 2 was all that we were forced to be certified at, we were not allowed to let our web redirects be out of scope. They just didn't let us. So even though version 2 is supposedly, all we're supposed to be held accountable to, our hospital purchasing system, our campus credit card websites, even though there's a redirect involved, they told us that if the website has a landing spot for somebody to purchase something, it's in scope.
So I think you know you're changing auditors, because we have an auditor that's very well that's a well-known escape, if you will, from PCI, at least with our audit.
Be careful, because like he said, I think you may have got away with it, and the reason the reason that they would not let us out, and we actually checked with a few others, we got second opinions. The reason is if the website is compromised, it can become a man-in-the-middle attack. And so if somebody screen captures your purchasing destination and they compromise you in the middle, they take over your button, they redirect you out to their man-in-the-middle lookalike, and then they're all of a sudden collecting your customers' payment card information. And so that's why they are now, I mean, it's going to be very hard to find anybody who will let that website not be in scope.
They basically were saying that we were responsible to get them to the right place. That was still part of our responsibility as part of the PCI framework. But you are right in that I kind of took your analogy of the traveling in basketball. You have all these concepts of what constitutes traveling, but it's a referee that decides if you travel. And I take that into PCI. PCI has all of these standards, but it's the QSA that decides what's in scope. Do you have, if you've got, because we also have to put up a PCI Active Directory component, because if we had any part of that as part of our normal Active Directory, that QSA was saying your entire Active Directory solution is now in scope.
We've done that. We've done a separate Active Directory.
And so, but again though, he came in and looked at what we had and made a determination of what was in scope and what wasn't. And so we did have to, the redirect, it does say in the standard a redirect, but redirect is a very generic term. And they took it to the point where we ended up standing up a new virtual environment for just our 8 to 10 applications that did that redirect. And we quickly decided we needed to consolidate that down. So instead of having 8 or 10 different applications that do the redirect.
So are you meaning by redirect that you send it to a commercial?
Yes.
So we have hundreds of those.
So,
but a part of PCI was that your servers couldn't, anything that was into the POS system or on the PCI system couldn't have internet access or open internet access. How do you have a web server that's offering service to anyone?
Well, ask Neiman Marcus, ask Target. There were servers that were compromised through multiple layers of infection, and that's where they're getting now, to the point where they're just, it's just they're trying, and granted, it's, there's lots of, there's lots of a spectrum on this, and I hope none of you are dragged into this at the level that we've been dragged into it. But the fact is, it's worth considering and realizing that if the organizations you're working with decide to come back and say you are one entity and not just an individual set of 100 merchants, or not a bunch of individual merchants, it is very likely, that you'll be forced to do a level 3 certification, and it's very expensive.
So I'll comment on that from CSU's perspective. Our acquiring bank has viewed us as a single entity since PCI began. So we have been one entity submitting one annual self-assessment the whole number of years we've been doing this. The version, moving from version 2 of the PCI rules to moving to version 3 of the PCI rules, which took effect about, what day is it? About 14 days ago, with the start of the calendar year. The rules are much more explicit. So under version 2, there were interpretation documents posted on the PCI website talking about best practice interpretation for scoping and what that meant for websites and redirection. version 3 of the rules that apply to everyone talk very specifically about the notion of whether a website is in scope if that application redirects the authorization traffic to an external vendor, whether it be authorized.net or something like that, and that the man-in-the-middle attack that was just described is very clearly spelled out as the reason for changing those rules and strengthening the notion that that server is now in scope. And yeah, that creates a lot of hassle for us. Then the other threshold that we were talking about throwing terms around is the merchant level. So as a single university entity, we used to be a level 3, which means more than 20,000 transactions a year, but less than 1 million a year. And in the past 6 months or so, our rate increased enough that we are now over 1 million transactions a year. And so we're a level 2 merchant now. We're still able to do an annual self-assessment. We're not required to do an on-site assessment by a certified partner. We still need quarterly network scans of our PCI environment, but we define what that is. We've carefully segmented with firewalls all of the pieces, parts of our credit card environment, with the exception of we need to true up that set of web servers because of those new scoping rules. And then a level 1 merchant, which is defined as anything over 6 million transactions a year for the entire organization. That's where you get into a required annual on-site assessment by a third party. So unless you're
my numbers wrong. Thank you.
Yes. So level 1 over 6 million, that's where you have no choice about hiring someone to come in and make all these determinations for you. Up until then, at level 2, whoever's doing it internally for you is required to gain certification through PCI as an I forget what the acronym stands for, an ISA, internal security auditor or something like that. So that's a training and annual certification with a paid test, and we're just entering that phase. But so far we have not had someone come in and charge us an arm and a leg to go through what I've been going through myself with the help of 2 members of our banking services team for the last nearly 10 years now.
Well, I'm glad to hear there's somebody else that's been treated as an individual entity, because like University of Washington in the Pac-12 with us, we like to talk a lot with them because they have a medical school like we do. They, other than the fact they're bigger than we are, there's a lot of things we have in common, and they're not being held to the same PCI standard we are. They're still being treated, each merchant account as an independent merchant account, and everything else.
So that's your bank's call, and our bank has always treated us as one. So sure would be easier if they were a whole bunch of individual merchants and we could just let them fill out a simple form.
Go ahead. You have a question?
Yeah, I'm just curious. I mean, we have on our campus have done essentially everything we can. We have outsourced all credit card processing. We know credit card numbers. Done everything we can to get away from as much PCI as we can. With this stuff with website redirects and stuff, at this point, it sounds to me like there isn't any way to accept payment via credit card and avoid
There is,
PCI.
and we're piloting it, and it's actually part of this version 3 stuff, I'm told. I wished our CISO was here because he's the one that has all the compliance stuff off the top of his head. But basically, there is an industry popping up where you can purchase an end-to-end encryption device, and you basically put on the desk an encrypted lockdown device that some owning entity has the keys to, and it takes the credit card information, and then that entity that's owning the point-to-point encryption and owning that system that you're purchasing has all of the PCI accountability. And so,
how do you do that on the website?
well,
Right.
and that's where the redirect, the redirect is still going to be a problem, and you may have to use like a hosting service, or even do like we did and just have a PCI farm that's specific to those applications.
Or somehow to get PayPal to be your front-end store.
Well, I'm just wondering though, I mean, at some point you would have to redirect to the hosted site that has the redirect.
It's redirects.
How many redirects do you have?
Well, and that's an important point. Is
Redirect more than 3 times.
that was, kind of our question was, how far up the chain can we go with redirects to really have only one point be in scope and completely put that all by itself? And
So the notion in the new rules is that anything that can directly affect something in the cardholder environment is also in scope. So the web server that holds your payment button is now formally in scope. And so one thing you could do is outsource your payment applications. Outsource your e-commerce server. Have someone run your entire catalog and application that allows people to choose things and make a selection for what they want, and the payment button would be just a part of that outsourced solution, rather than an application running on a server on your campus that interacts with accounts receivable and inventory and all that stuff. You outsource the entire merchant function, then it's a pretty trivial process.
So they haven't chosen what they're going to buy yet?
So Steve, the payment button's in scope, but is the shopping cart in scope?
Well, this is where we get into knockdown, drag-out fistfights with interpretation of these rules. You could build some multi-step process and radically protect the last step, and maybe what that means is that the shopping cart is in scope and you outsource the shopping cart.
So 2 questions. One, if you outsource the whole e-commerce server, then the link to get to the e-commerce server is still in scope. So you just have to have
Not necessarily.
Well, if you can put up a shopping cart that looks like it, and your server's hacked and you redirect them to the whole full site, what's the difference between the payment where they still have to log in and you're scraping it, or where they go to another site?
This is where secure certificates and things do help give you some protection. If you outsource it and there's some sort of valid VeriSign in the handoff or whatever going to that outsourced solution, then in a sense you're putting an incumbent, and the QSA would support you in this. You're putting the incumbent trust upon the security infrastructure that we are all relying on for secure HTTPS to get you to where you landed. But your credit card will then be given much later in the process. You're just directing them to a website. You're not giving them the credit. You're not implying anything. You're just handing them off.
But right now, my payment button, I click a button and it comes up, and there's a whole new website and says you're now at a payment processor. You have to log into that with credentials. So it's just like a shopping cart at a remote e-commerce site. I could say you should shop at Amazon, and it would do the same thing. And it would pop up a window. You would log in with your credentials. You would give the payment. It would somehow make its way back through us. The only thing I'm giving you is a reference of what some ID that I referred you to. And then so it's a complete system. I don't see any difference between that, because I could get a certificate that's kind of like Amazon.com, and it would look just like that, and I can buy certificate.
That's where you have to go to have, you just have to have a QSA answer.
So my second question is, would 2-factor authentication solve any of this? Where there's one-time passwords, where they would actually have to have an authentication before the credit card information went through, do you think, have they addressed any of that, where maybe we could leverage our existing two-factor, not 1.5, but 2, to maybe get there so there's another validation before the credit card gets put in?
Steve, you want to answer that?
Well, so typically the use for two-factor authentication in PCI is for securing your servers against remote access by administrators or by vendors. What we're talking here is a man in the middle where the vendor site is spoofed and the customer is taken to a rogue site. So sure, anything that you do that gives added assurance that you're really going to the real site will help. And there's no reason that we can't create a PCI compliant e-commerce solution on our campus with a properly scoped and segmented secured environment. It's just that it raises the level of work to a level that we hadn't had to deal with before. If you want to use outsourcing to do that, I think it's instructive to think about the PayPal.
And by the way, I may have to ask you to edit that last piece out on the recording, because I don't want that out on the web. Alex, take care of that for me.
Okay, Linda, we had enough of this stuff. I'm ready to go. Alex is last on the. All right.
Thank you.
Try to do that.
It's all in a mess. We have to put a system in our critical because we have a hospital. System that if something's giving us a credit or they have to press a button on the phone, it pauses your code so the credit card will for the credit card. For the entire recording system.
Well, let's make it really fast because we can't.
As long as you don't have call recording, because once if you're recording this credit card numbers,
So we have a voice generate our voices. That's different than 18%.
All right, so I'm going to talk to you about Noah's TIC effort. Kind of outline what I'm going to go over, what TIC is, what the goals are around what Noah did for the TIC. What were some traffic symmetry solutions we had to some different options we looked at to solve the traffic symmetry problem. Go over in detail some of our NOAA TIC architecture and kind of announce a new X-Wave network and our SANS DMZ that kind of goes along with that. For those of you that don't know, back in 2007 there was an OMB mandate that said basically that the federal government had reduced the number of interconnection points between the federal government and the internet down to 50 locations. That was kind of ridiculous in that NOAA by itself probably had close to that number of internet connection points. So that has since been relaxed, and NOAA on its own has 4 approved TIC access points. What other agencies generally do is they contract out their TIC service to the service providers through a program called Managed Trusted IP Service, MTIPS. And that works well for most agencies because they have low bandwidth requirements. They're just giving park service, public data. This is when our park's open, kind of stuff. But for an agency like NOAA, where we move a lot of data out to the research community, it would have been cost prohibitive, and they probably couldn't even provide the level of bandwidth that we would have needed. We also wanted to develop our own solution so that we could gain some visibility into that security architecture, because when you contract this out to a service provider, they're pretty much a black hole and you don't know what goes on. TIC version 2.0 reference architecture, pretty traditional. bad stuff over on the left side. That's the internet. Your internal zones are on the right side. And then what sits in this tip zone are stateful firewalls, web proxy pieces, an Einstein box, which is a DHS-operated piece of equipment, and then the capability of providing packet capture, full data packet capture of everything that goes in and out for, I believe, is up to a week's worth of full flows. So that gets to be pretty large when you need a lot of data. And those Einstein pieces, that Einstein box is the way that DHS gets a view into any coordinated attacks that are happening throughout the federal government. So they'll have these Einstein boxes at all the TIC locations. And again, all that data gets sent back to DHS so they can get a consolidated view of traffic that goes in and out.
Alex, what do they just monitor all the time? That's what they do?
DHS?
No, the Einstein box.
The Einstein box, yeah. So it's essentially an IDS kind of thing, and it's looking for traffic signatures. And I don't know the particular architecture of it, what it does, and how it does it, but
it's just take care of you.
Yes, it is given to us, and it has seals on it. You can't open it.
Alex, that's also capturing all of the packets as well as storing them for a week.
So the Einstein box is not doing the packet capture. It's just a, it's shown inline here. We're actually not going to deploy it inline in our architecture. But it's just a inline device, and it's not doing any packet capture. So the packet capture piece is a separate thing. That's part of the requirement of the staff, but not the Einstein box is actually that can do the packet capture.
If it were an inline, it could do IPS stuff as well. So
it could. But again, that's not a function of Einstein. Yeah. And there are architectures that are deploying IPS. NOAA is choosing not to.
Okay.
So the Einstein does a full network tap, or not a net flow or a percentage? So
correct. Full network tap. So these are the TICAP locations that NOAA is deploying. 4 in the CONUS, Seattle, Denver, Dallas, and the DC area. There is a 5th one that hasn't been approved by DHS yet, but we'll likely get approval soon. It's operating in a multi-agency standpoint, whereas the other ones kind of aren't. So multi-agency means we're going to provide service to agencies beyond just NOAA and Department of Commerce. The one in DC probably will become a multi-agency TICAP as well. We're going to go in partnership with the MAX out there, and they provide a lot of internet connectivity for a lot of civilian agencies out there. And we see a lot of demand for it out there. The MTIP service is expensive, and again, they don't get to see what's going on. So all external, non-government traffic will have to flow through one of these 5 access points. Fortunately, we have one in Denver, so the impact should be fairly low for the Boulder components. But we have other labs that are located, say, in Norman, Oklahoma, that are currently getting, or were getting, free internet service from the University of Oklahoma because they were co-located on the campus. They had, 10 gig connection to University of Oklahoma that got them out the internet. Now we have to get them backhauled to one of these TICAP locations, and their communications, say, to their neighbor next door has to go through one of these TICAPs. So what were some of the goals for our deployment? Obviously, we had to meet particular requirements, including traffic symmetry. So having a stateful firewall in there causes all sorts of problems, basically because of this traffic symmetry requirement. We wanted to maintain resiliency, avoid single points of failure, give us the ability to scale and grow this to accommodate both our small weather forecast offices and our big research centers. And we wanted to have good utilization of all our network circuits, our various entries and exit points at those TICAP locations to make sure that they're efficiently being used. So the different traffic symmetry solutions we looked at, we could have it where a remote office connects up to a single TICAP location all the data goes in and out of that single TICAP location. That's kind of similar to what we're doing, or what we did pre-TICAP. It's the simplest solution, but it gives us poor availability. So if one of those TICAP locations were to have a bad day, it also gives us difficulty in growing and scaling things because if say Boulder gets full and we have someplace close that needs to connect up to a TICAP, shipping them over to DC doesn't make a whole lot of sense. The second solution we looked at is to have a particular remote office connected to two TICAP locations, say like in Denver and Seattle, but only use one as their kind of like a primary and a backup. So one is a hot standby. Problem with that, there's a couple of problems with it. One of them, it's difficult to ensure that that backup's always going to work unless you put it to use. And then some of these offices are fairly small and very low networking expertise, so pushing that requirement of dynamic routing in effect on the small offices can be difficult. So the final solution we came up with is have the office connect up to an entity, nWave, that controls traffic routing on both sides of the TIC stack. So we have a single entity NOAA network, not a single network, but a single entity that controls both the NOAA communications on the inside and the NOAA to outside communications. So therefore, we could enforce that traffic symmetry. I'll go over examples of what that is here. So here's an example. Let's say an office in our Sandpoint location sends traffic out through our Seattle TICAP, and it goes out to Internet 2. The end customer returns the traffic back to Internet 2, but then Internet 2 decides, for whatever reason, they have more bandwidth than Boulder or whatever, they decide to send the traffic back through Denver. We can provide hints via AS path padding or BGP meds and that kind of stuff to try and influence traffic to stay symmetric, but we can't guarantee it. So in this instance, the return traffic could come back through the Boulder TICAP, and we break that symmetry problem because the two different firewalls and the two different TICAP locations are not tied together. So if we do have a network that controls both the inside network and the outside network, the one below and the one up above, we can have communications between those two networks and ensure that traffic that symmetry is restored. So take that example again. Internet 2 sends traffic back to Boulder, but then Boulder that external network will send the traffic from Boulder to Seattle so that you can go through that firewall in that Seattle TICAP location. So NOAA's current networks, that lower NOAA networking bubble, is provided by a couple different separate networks, nWave being one of them. We also have other internal networks that provide node or NOAA connectivity for other life and property missions that don't necessarily align well with nWave. So things like our OpsNet, which the Weather Service operates. So those will continue to operate. NOAA will continue to leverage our commercial and R&E partnerships in with the RONs. And we'll use nWave where applicable to provide that TICAP transport. So for a remote office to get through a TIC location, and it lines up well with the nWave footprint, we'll be able to provide that TICAP transport for those remote offices. And that new network, external peering network that I mentioned, is the new X-Wave network that's kind of born out of this effort. So this kind of goes over how we'll use nWave to provide that TICAP transport. So we have these various offices at these edge locations: Miami, Norman, Oklahoma, Charleston, Nashville, etc. So we're using nWave to provide then transport back to, again, these TICAP locations, which are conveniently align well with our core locations, except for the Dallas, Texas area. So that's going to have to be a new build when we get there. This is kind of our interim TIC architecture. So this is going to be before we deploy our X-Wave network to the outside. So each of the TICAP locations are going to be more or less silos, more akin to the way we're operating currently. So connections to the gigapops for RME and commodity internet access. One thing I want to point out here, we are going to be locating the border routers at the top, the aggregation routers at the bottom, at our major metro areas rather than at the NOAA facilities. So take the Denver location as an example. The NOAA facility is actually in Boulder, but we're going to locate, again, all the gear, the border router, the aggregation router, and the inline TIC pieces, which is the firewalls and the web proxy pieces, up at the down in downtown Denver at the pops down there. And the rationale behind that is for the remote offices, it doesn't make sense for them to send their traffic to Denver, go to Boulder, and then in order for them to get back to the internet, send it back to Denver and then on out. So it just saves that hairpin turn for them. So we're going to try and do that in Denver, in the DC area, Seattle, and in Dallas. The piece that I am showing at the NOAA facilities, like in Sandpoint, Boulder, Fort Worth, and Silver Spring Metro Complex, those are the kind of space and power hungry pieces. So essentially the packet capture pieces, the out-of-band Einstein monitoring piece, and IDS pieces. So we'll have those back at the NOAA facility just via a mirror port off of the aggregation router. So it's not, again, it's not an inline piece. So again, just more, I think I've went over all these points about X-Wave. It's going to provide us a new way to peer with the internet, something that NOAA's not had in the past, something more akin to what ESNet has and NASA has in terms of a single external network that can peer with the various internet partners. And we're going to hopefully deploy science DMZs for public data delivery as a result of that. So this is kind of the end game architecture where the X-Wave network is in place to provide that communication level amongst all those border routers out there and provide that rich peering to the various internet entities out there. And as much as there is a typical science DMZ, we're planning on deploying a science DMZ out there. So the big data that gets served out to the public will put out at these science DMZ locations, which are outside of the firewalls that are in the TIC stack. So if someone out on the internet, in car, university, in order to get to this data, we'll hit our border routers and then get to our science DMZ switch routers to get the data without having to, again, incur the problems that the firewalls can introduce with packet loss and other perturbations that they introduce. We plan on deploying security in the form of similar to what Steve Boulder has with a Bro cluster and providing a scan or mirror of that science DMZ switch out to our Gigamon, which then feeds out those various Einsteins and IDS PCs. We're going to explore using Linux containers for our data transfer nodes because there's going to be a lot of various data delivery methods that we're going to have to support. Globus is one of the newer ones that we're pushing, but there's a lot of older data delivery methods we still have to support, HTTP, LVM, and various other things. And Linux containers gives us the ability to overcome some of the problems you have with virtual machines, and that abstraction layer can cause problems with accessing the NIC and doing the high bandwidth transfers with virtual machines. I think that's it. So I said I'd keep it short.
Yeah, are you using taps for?
So no, actually there are no taps. So the mirror port that provides the AmeriPort that's providing the feed to the ISAP box is actually going to be AmeriPort offer aggregation routers. Because even though I show a single stack, single devices, it's actually a full mesh. There's 2 devices, 2 firewalls, 2 aggregation routers. So it's a pretty yeah, it's difficult thing. So the plan is to provide that mirror to the Gigamon, which will then farm out the feeds and the various pieces.
What did it cost? No.
That's what I was just thinking, what does it cost the nation in order to secure this data?
Another one is unfunded mandates that we have to deal with as well. Fortunately, a lot of the pieces were already there. I don't know actually how much that's security stack costs. So,
Sure, you know what to put it all in once.
Any other questions for Alex?
That's pretty cool.
How's the solar project in the attic?